We handled, as Doc talked about, the diagnostication, how we did it, okay? We actually handled, in my shop, all drivability problems almost in the whole Philadelphia area from dealerships and other garages. I had 2 general repair shops, but I also had this diagnostic shop, all right? And I found out that what I had to do, I had to come up with a plan. There's no way in the world we were going to handle 22 to 28 cars per day, every day, with a 2-week wait, unless we had a plan. So one of the plans I always had was waveforms. Has anybody had the pleasure, now this is 19 years ago, he deceased, anybody ever had the pleasure of sitting on a Tom McKenna seminar class? Anybody remember that name at all? 25, senior, not juniors running around, senior. 25 years I traveled with the guy, and I swore he could tell you what's in your glove box by looking at the secondary pattern. All right, so what would happen? You know, we got the big scopes and everything else. I'm going to tell you how this course actually started. I'm going to be honest. I do a lot of classes all over the place. I do a lot of classes for cars and ACAT and all that stuff. What winds up happening, if anybody's ever attended anything like that, you have maybe 12 to 14 classes going on at one time, KC Vision, all these places, okay? So they asked me to do a class, and I said, okay. And I didn't want anybody to come. I want to go to other classes. So I said, I know what I can do. I'll do secondary waveforms, and nobody will show up, and then I'll be able to go wherever I want to go. Boy, did that backfire. And here's what I want to try to accomplish. We're going to do this in 2 breaks. I'm going to half of it, and we're going to take the lunch break, and then come back. First of all, I don't expect anybody. I looked around. I didn't see any big scope fenders. I don't expect anybody to run out and get a big scope. Here's what I'm a little bit tired of hearing about, though. I'm a little tired of hearing we really can't do that stuff anymore. Okay? We have cop ignition and everything else. Okay? Well, the end result is that with primary, I don't know about you, but I learned something a long time ago that secondary comes from primary. And I can't tell you how many times that I'll get an email or phone call from another shop, and they tell me about a problem on a vehicle, especially when they talked about secondary. And I said, okay, well, what does the primary look like? I don't know. I haven't checked that yet. I never understood that because that's where it comes from. So the first thing I want to do is I want to show everybody, I'm going to go through this. And ironically, as I was taking notes down during Doc's thing, and there's so many things that he said that are so important to what I'm going to tell you. If I ask you right now, what do you think the real theme of Doc's seminar was? I'm going to say it was basics. He was covering basics. You know, do you have power? Do you have ground? Okay? Well, there's 3 guesses of what I'm going to be talking about. It's all about piece of the puzzle, you know. It's this logo. Picture Sherlock Holmes. I didn't start that. If anybody remembers a guy named Joe Woods. Joe Woods traveled around for 3 days with me, and he gave me a handle. He called me Sherlock Holmes with a wrench. And what he said in the article, he said for 3 days he watched me put the piece of puzzle together. This is just one of the pieces of puzzle. And if you don't run out and buy a secondary oscilloscope tomorrow, right, or Monday, it is okay. I want you to see a little bit of what kind of goes on in the combustion chamber. And ironically, I wrote this course a long time ago. I keep tweaking and everything else. If I had not written this course, I could just talk about what I saw last week. Literally just this week. I don't know how it was up here in the Philadelphia area. It was unseasonably warm. And in case you don't know this, we have winter fuel 365 days a year. All right, so literally my email was clogged completely. My phone was running off the hook of all these problems. You know what the very first thing I said to everybody was? Does it do it in the morning? Does it do it in the evening? You know what? I think, no. You know what? No, it's not. You know, it's the afternoon. Oh, geez, that'll be when it's really hot also, right? And that's what I talk about with secondary patterns. I am not allowed to mention the name. I'm a consultant for a couple of manufacturers also. Major automotive manufacturers out there talking about how the cop coils are all failing right now. It's not the cop coils failing. What's happened is the cop coils are working too hard. Everybody in this room should understand some basic things. Lean air fuel ratio and high compression are the hardest things to fire. That's why back there with the carbon cleaning and stuff like that, you've got to get the carbon out of these cylinders. And the end result is that, thank God, everybody burns the right octane, right? Who cares what the price is? We're always going to burn the right octane, right? Nah, No, that doesn't happen, right? So the end result is we're raising compression due to carbon. And then we also have this stuff called winter fuel, or oxygenated fuel, E10. And if you don't know this, alcohol has 2.5%, 2.5 times more oxygen in it than regular fuel does. So we have double, if you don't know this, 5 or 6% alcohol was in winter fuel. Now we have 10%. And the ironic part about this, where I think this is really going to be beneficial about this, what I'm going to show you right now, if you don't know this, E15 has been approved. And they say 2002 and newer vehicles can take E15. Well, I'm going to tell you personally, I have a 2006 Dodge Dakota out in the parking lot, and I'm going to guarantee you it's not going to move in a forward direction with E15 in it, because I'm having a hard enough time with E10 in it. And what I'm doing is I'm destroying my cop coils. And that's where we want to go with this, okay? I don't care if you really ever look at a waveform. Understand what happens in a combustion chamber. I would like everybody to become Sherlock Holmes at a wrench, and when you're trying to diagnose things, and put the puzzle together. Just put the puzzle together, all right? It's really, really remarkably easy once you actually see it out or laid out, okay? Let's go into this a little bit, okay? We're going to discuss ignition waveforms, understand between primary and secondary. Okay? We're going to go over voltage over time versus current over time. I was walking over here looking at different things and everything, and I'm going to be real honest with you. I don't look at voltage over time. We were all taught, everybody in this room, we were all taught to look voltage over time. All right? I'm also a post-secondary advanced engine performance instructor. One of my former students is sitting over here. And the end result is that when I teach post-secondary, the first day, what I tell those guys is that don't ever be late and don't ever sleep in my class. So that's all I have to do is just say that, right? It'll never happen because I gave a command, right? Isn't voltage over time a command? What do you see how many times I'm going to show you today? How you hire the most beautiful looking commands. And why did that shop that sent the vehicle to us say, you know what, they say all the time, they say, here's what we know. They're going to save money and save time. It's not this, 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 it's not this. I said, if it wasn't one of those things, it wouldn't be in my shop. Current over time is the actual work, isn't it? I am mystified of why we keep on going and looking at voltage over time. All right? Amp probes and mini-amp probes. I'm going to tell you right now, I would not leave home without, I'm constantly looking at the physical work. Why do I have to look at the command? If the work is there, isn't it the command had to be there, right? Where do you see how many times I show you the command? And where do you see what the work, the quote-unquote, what the work looks like, okay? So we're going to go and understand the specific portions of the waveform. And I'm kind of ironic before I start this. I was in Sanibel Island doing a seminar. And just like here, somebody was in front of me. And that person said something on stage. And he got off the stage and I got on the stage. We crossed each other on the steps and I turned around to him and I said, when did you attend atomic mechanics seminar? And he stopped dead. And he goes, how did you know that? I said, you said something that I've never heard anybody ever say before. Now, Bernie Thompson talks a lot about this also. I'm going to go into a little more of a detail. And the end result is that I told him what he said. And he says, you know what? I couldn't remember where I heard that at. You're right, it was him. Now watch what I'm going to do with this waveform. And I guarantee you, by the end of my session, you're going to know a whole lot more how to put the picture together. Okay? First of all, we don't need a big, fancy, expensive equipment. That's the number one thing. Everybody thinks I'm going to sit there and say, you got to go out tomorrow and buy a big scope. I want you to understand equipment, though. And we had equipment out there like anything else. I talked to Doc last night. Doc had a really good program years ago called Target Training. Anybody remember that? And no one bought it, you know, so it went away, right? It was a fantastic thing. We don't learn about how good things are sometimes until they disappear. Well, here's a perfect example of that right here. All right, that is called a KV probe. All right, now keep in mind what I'm trying to walk you through. My diagnostic shop had 3 technicians in it, and me, the quote-unquote owner. I would get each one of my techs started on a diagnostic job, and then I'd go out, the quote-unquote, they call me the milkman, all right, because I would go out with my little tray with all the little things in it, and I'd go out and try to figure out basic testing. So my guys say, every time we look out there, you look like one of an old milkman out there and stuff, you know. That's one of the things I would have in my tray. Has anybody ever seen that KV probe? Anybody have one of those? Okay. The end result what that does is that you turn the thumb wheel on the thing, you hook up the secondary ignition wire, turn the thumb wheel, and when your light stops blinking, you're at the top of the firing KV. Okay? What you're trying to find out, what I'm trying to find out there, are all the cylinders even? Or do I have a high voltage or low firing voltage? Very simple. I want everybody to remember this whole seminar. An L. Okay? You got your firing KV and your burn time. Okay? If your firing KV comes down, your burn time extends. If your burn time shortens, your firing KV goes up. You only have that one piece of rope. Okay? I want everybody to take a little bit of notes also here. Remember this. Everybody comes to me all the time. Well, what should my firing KV be? What should my firing KV be? My response back to that question all the time is your burn time should be 1.0 to 1.5. 1.0 to 1.5 milliseconds. Okay? And they say, well, wait a minute, hold it. You didn't hear my question. I asked you what my firing KV would be. And I say, your burn time should be 1.0 to 1.5. And if you have a newer car, it should be 1.0 to 1.2. Okay, I wrote that down. Now can you answer my question? Nope. Because I don't care what your firing KV is. If your burn time is 1.0 to 1.5, whatever your firing KV is good for that particular motor. Anybody know why I said a newer car should be 1.0 to 1.2? Because the federal government's all over the manufacturer, the car running leaner and leaner and leaner, right? And what did I already tell you? Linear fuel ratio, right, and high compression is harder to fire. It's very, very, very simple. What do I see all the time? I see 0.7 burn time. I see 2.2 burn time. And there's a very specific reasons for it. Okay? So the end result is, now when I show you, this is there. Anybody have one of these little tools here? It's a little flag on it you put on top of a cop coil, right? Anybody see the Generation 2 one now? This one here, what it does, when you lay it on top of the cop coil, it flashes. And that tells you the cop coil is firing. Now, I can wet my finger and put it on. I probably feel that too, right? If you don't understand what the second one is, the new generation, that's got a little bit extra, a little bang for the buck now. There's two lights on it. The second light is if the duration or the burn time is long enough. So if you have one light blinking only, you don't have the second light blinking, what you now know is that your firing KV is very, very high, and your burn time is so short that it's not firing off the second light. I would say the only negative to that is that if your firing KV is so low, your burn time could be as long as this table, I guess, you would still get the flashing light. But I'm into quick, easy. I teach all over the Philadelphia area, and now I've been going over North America, actually in Canada and everything else, teaching a thing called G's and P's. And if you get nothing else out of this seminar, remember what I'm telling you right now. I get paid. Now, let me rephrase that. My wife gets paid. Right? There's a corporation, Matt's Corporation, Morton's Automotive Technical Service. There's one worker and there's one boss. Right? I'm the worker and the wife is the boss. Okay? But what happens is that I get paid sometimes to watch it, go into dealerships especially, and watch the techs work. And how I report, I got a piece of paper and I write down on a piece of paper as I watch the techs work. I write P's and G's. All right? And the end result is that, am I pinpointing, is that test he's doing P's and G's, is that tech doing a general test or is that tech doing a pinpoint test? All right, what I mean by that, I've been up against, I'm going to say, like John and Elle, I've probably been up against 50,000 problem cars also. And the end result is that my first job is always, always, always to get in the right area. And over the years of working on all these cars, it's going to be drivability problem, it's going to be ignition related, it's going to be fuel delivery related, or it's going to be engine integrity. And the faster I get into the right funnel, all right, the better off I am. In my shop, we had a 15-minute rule. If you weren't into the right funnel in 15 minutes, I didn't know what to say anything. My guys would just switch and fresh eyes on the job. That's the only way you can get 22 to 28 of those cars done every day. But the end result is once you're in the right funnel, and that's what we're going after here, stay there. Give me a reason why you should come out of that fuel delivery funnel once you like I start the car up on propane. All right, I drive it in, and there's no ignition in that, and there's no engine integrity in that, right? It's fuel delivery problem. Why would I even think about looking at anything else? That's why I see a waste of time all the time. You've got to believe in yourself, or whatever it comes down to. You've got to believe in your diagnostics. All right, so we're going to walk through this now. The end result is that there's a lot of neat equipment out there. Has anybody seen this yet? This George, anybody's ever been George Mesha? George has been here a couple times. George and I do a lot of things together. George has designed a thing called a U-scope. That's the new one right there. That's the waveform, and that's the cable for it. The U-scope is about half the size of my iPhone. All right, so literally, do I need real expensive equipment to get waveforms? First thing I'd say to George, later on I'm going to ask some of you people this also. That's George's picture on his site of a secondary waveform. And I said to him, George, why did you put a problem waveform up there with high resistance external to combustion chamber? And he goes, I hate sending stuff to you. You know? I said, George, it's so plain. And he said, what are you explaining to me? And now later on, everybody's going to be able to pick that up. That is a problem cylinder, and the problem is external to combustion chamber. All right? Remember I said that. Here's what we're going to get into. As Doc said, I was listening. I was so common. It's kind of weird that we have 3 seminars going today. And while I was sitting in the traffic on the New York freeway driving up here yesterday with cars on fire and everything else, I was thinking about the 3 seminars. Does everybody realize how closely related they really are? They really are, is because number one is that what Jerry's going to do, what G's going to do, he's talking about PO420s. I've seen 1 or 2 of those. All right. Per minute. Yeah, right. Yeah. And everything, PO420s come because low gas efficiency. Okay? Well, everything I'm going to show you is all about how efficient the engine actually is, right? And then very simply is that why we have so many quote-unquote drivability problems now that I won't be talking about is because the federal government basically said, get the car running better, get the car running better, get the car running better. And guess, you ever hear that cliche is watch what you wish for? Well, what happens when the car runs better? CO2, carbon dioxide, right? So what do we have to do? We got a choice. Either make the car run bad again or turn the engine off. And that's what Doc was talking about basically all morning. So these aren't really 3 separate things. They really are related to each other, all right? Anybody remember that picture there? Anybody ever have a thing called a Fluke 98? Okay. Here's another thing I just told you. When something is awesome, a lot of times we don't purchase it, and what happens, it goes away. Okay? I had a Fluke 97. I don't know if anybody ever saw 97. Unless you did what I did every day and had a lab scope in my hand literally 8 hours a day, a Fluke 97 was pretty intimidating. Okay? With nice scope, it was a little intimidating though. So if you don't know this, Corey Glassman from Fluke and George Mensa from AES got together and designed a thing called a Fluke 98. And they make it more user-friendly. Okay? What you're looking at right now is a battery test. Geez, I thought that this was a class on ignition patterns. Well, see, this is what it all comes back to. I don't know about you. I'm sure nobody here ever did, but I lost my butt so many times by jumping right over the basics. And when I got 22 to 28 cars every day, I'm going to make sure that I have the basics. If my guy did not do this test, I would have been all over him. You know how many times I have flown? I became a troubleshooter for factories. I followed up behind the factory troubleshooters. And you know how many times that I flew across the United States and told somebody, you know what all those drivability problems are? You got a bad cell and a battery. So I always joke about this. I had some issues. It was in a couple of magazines and stuff. I had some issues with my heart a couple of years ago. And I gave up my mobile diagnostic business and basically just doing the seminars now. But the end result is that I said if I ever start my diagnostic business up again, I'm going to call it, you got to be effing kidding automotive. Because every time I told somebody what was wrong with a car, they said, you got to be effing kidding. You know, no, a bad cell on a battery. You know what's really weird though? Who's got a computer in your office or your home? Okay? How would you like to go and take the 110, 120 volts going to your computer and cut it down to like 85 volts? How well do you think your computer would work? But yet, we don't seem to understand that if we got a bad cell in a battery, or we have any way, shape, or form of a primary voltage problem, it's going to manifest into the secondary. It's a real simple thing. So I guess that I had to learn to lose my butt over and over and over again before I finally realized, you know what, I'm going to take the extra time on every car and make sure of something. So we went out and I bought 3 98s, Fluke 98s. And what's cool about this is very simply is that what you did is you hooked up, really hard test, hook up to the battery. All right? When you hook up to the battery, what happened was right there, you would get your open state voltage. And what it did, it transferred up here. That's 12.8 volts. And then, correct me if I'm wrong, when you crank a vehicle over, what happens to battery voltage? It goes down, right? And we all did the VAT-40s and stuff. We try to stay above 9.6 volts for 15 seconds. Well, McKenna's, that's why I asked anybody ever attend a McKenna seminar. McKenna told me all the time, if anybody ever walks in your shop and says, when I put a VAT-40 on my car starts to do this and that. He said, they do that to use a VAT-40. But if they don't say that, they say when they're driving their car, when they start the car, why don't you use the things that are on that car? That was the number one thing he always taught me. You know, he believed in equipment, but he also believed in use the car. Use what's on that car. But you're trying to find out what's happening to the battery voltage. So you crank it over and look what happened. This one here went down to 10.1 volts. All right? What it did, it transfers that number right up there. And then what happens is you crank the vehicle, and this area right here is called CEMF, counter-electric motive force. If I ask somebody right now, let's get an engine, bring an engine here on a stand, and let's crank it over with a ratchet and socket. If you turn it over about 3 times or so, and I'm going to turn it over 3 times, but you're going to do the first one, I'm going to do the second one. As you're coming around your third one, I'm going to grab the breaker bar, I'm going to keep moving it. Don't I have an easier job than you? You had to get it going, right? That's CEMF. Every part of this waveform, if you look at it, look at it, and look at it, it's telling you a story.
Can you say that
right?
acronym again?
Do what?
What is CEMF?
CEMF, counter-electric motive force. Okay? Counter-electric motive force. And that happens a lot of times on a lot of things. We'll get into that stuff. Look what happened here at the end. What happened at the end is it's above the area where I started, right? See, it says 13.8 volts. So what do I now know? My alternator is putting out 2, right? Look at this long consuming test. And what do I have right now? I got a pretty good idea that I can continue right now with the rest of my diagnostics, right? Okay, now hopefully somebody's sitting there, who cares? We can't buy this thing. You know, we can't buy this thing. I think it's pretty hysterical that a lot of the equipment I have, the same equipment you have, they tell you, you can't do this with that. You can't do this with that. And then I said, thank God I had already been doing it. You know, I would have known I couldn't do it, you know. So very simply, my point there is that here's a modus. And I don't care about any one you use. I'll just grab my modus here. I grab my modus, right, and I can do the same identical test because can't have Fluke 98 anymore. All my Fluke 98s have worn out, they're gone. Right? The end result is that I have plenty of other equipment. Why can't I do it? All right? The end result is, look what I'm doing right here. I'm cranking the vehicle over. Now, this is where I'm going to talk a lot about. No offense, I hope everybody in this room is a master of trigger. Watch how many times today I'm showing you trigger. No offense, what I see wrong in this industry a lot of times is either I'm really cheap, all right, or something, because I like to use every little bit of my diagnostic equipment. And if you know anything about trigger, and trigger is taking full command of the scope and making it show you what you want to see at that moment. So I'm not going to go and get a lesson in trigger, and that could take literally a couple of hours, but I'm going to point it out to you though. Look at the mark right here. See that X right there? What I'm doing is, if you look down this area here, what I'm actually doing, I'm triggering off of channel 1, which is the only channel I'm using right now. I'm triggering on a negative slope. That's what that means right there. And if I went over and hit this, the voltage would come up right here. I'm triggering at approximately about 11 volts on a negative slope, which means in layman's terms is that waveform is not going to show up on my screen until it meets my trigger requirement. So I take my leads, I put them on a battery, and nothing's going to be on the screen whatsoever. When I turn the key, battery voltage is going to go down, it's going to start. What's awesome about triggering, and almost all of them will do the same thing, it'll show the voltage before and after the trigger. So what happened here is that this is my open state. Now, it doesn't give me my numbers automatically like that Fluke did. What I do is I start the vehicle up, I hit the button right here, and I freeze the waveform, and then I bring my cursors up. When I bring my cursors up, I can move them wherever I want. I move cursor number 1 right here, and it's 12.75 open state. The next one is 9.31 right here, the cranking. And here again is my CEMF right here. It means it's getting easier to crank. Okay? I move my cursor over to the far end, look what I have. I got 12.26. Now, what I forgot to tell you about this job, there were six complaints about this vehicle, and not one of those complaints was in any way, shape, or form of about a battery or an alternator. Right? But what do I need? What do I need on this vehicle, like every vehicle, for everything else to work? I need an operating system. So wouldn't it be a smart idea to go after that stuff first? So what I did is, we went, it turned out that the connection on the back of the alternator was a bad connection, and we fixed it. What I have now, my second one, I did it again. There's my 13.11. Why am I over 12.66, 100% charge by? How come I'm 13.11 now? Surface charge, right? I could have put the lights on or something, dropped it down. I wasn't worried about that. Here's my surface charge, right? Also, what I've got my drop voltage right here, which is good. Here's my CMF, and right here, 14.19. Now, what a surprise. I didn't have to fix any one of those 6 things that was a complaint. Four trouble codes and 2 other complaints from the consumer. Everything was due to operating voltage. Okay? Now, here's what I want to try to really get into. What Doc was saying, and I'm going to keep on telling you over and over, is that pay attention to details. Doc was right about here someplace, and I never wrote it down, and he talked about you're following a path, and you're not really watching what you're doing here, okay? And then you go backwards and look at it, okay? What is this? That's, has anybody, I'm not going to take a wild guess, no, it's probably true here. Has anybody ever started a vehicle up and had a dim alternator light or generator light, battery light, and then you had hit the throttle, and then it went out and it stayed out now? What that's called an excitation circuit in the alternator. And what it means, very simply in layman's terms, is that the alternator's got to go over a certain speed to quote-unquote excite. And once excite, it'll start working. So ironically, I can't tell you how many times I've brought this into a drivability seminar. And I said, tomorrow, I just took this picture earlier, tomorrow I'll look at this thing. Can everybody give me a hand with this? What do you think I should do with this? And I'm going to be real honest with you, I don't have enough money for all the things that everybody wants to replace. That is good. And there again, that's mechanism at its finest. Know what good is. That's exactly what I want to see. Okay? But why do I see it sometimes, and other times I don't see it though? Anybody have an idea? I'm not going to see that every time. By the way, it's just, if you need to know, this is a 2004 Ford Ranger. So it's not an old car, it's not a brand new car, okay? But it's not making a difference what it is. How come I'm not going to see that all the time? And that's what happened. I showed people, look at this, man. Here's what I did it one time, another time I didn't, wasn't there. But what is happening right here, remember I told you we looked at it, we found a bad connection. The engine was still warm. So we started it back up again, warm engine. Right? Correct me if I'm wrong. A cold engine has a higher idle anyway, right? Because your IAC pulls back, right? So if I let this car cool off and it was cold, I would not see that hump. What would happen? Everybody in this room knows I have a higher idle, right? So the higher idle would take care of it then. So you might be saying, well, this is really weird. I see this sometimes and sometimes I don't. And with that all comes down to literally knowing your opponent. Know your opponent. I'm not going to waste any time. I guarantee you that waveform would have wasted hundreds and hundreds of hours in a lot of people's shops. Well, what's this? I got it fixed. Boy, I got something new now. No, you have something that you would see on a regular basis if you were doing this test. Okay? Now, does that mean that you can't do this? First of all, I used to say all the time, you don't really need a lab scope. Now I can't say that too many. The speed of signals today, you need to see the lab scope. Okay? I don't care what it is, but I mean, like that little thing George had, like $2.99 now. So my point is that you need to see the waveform and you get used to what normal is. And then you're not going to be wasting any time and stuff. That's what comes down. Time's money. Time's money. I hear people all the time, they tell you know what, boy, we fixed this vehicle, we fixed this vehicle. Okay, yeah. You start working on Monday, you finish on Thursday. That's called a hobby. It's not a business. And everybody accuses me a lot of times of flat rating. They say I'm a flat rater. I'm not a flat rater. A flat rater is guessing. There's a way of doing intelligent, fast, accurate diagnostics. But you got to know what you're looking at. Does all make sense? Okay? So we're going to go through this now. Here's what I find all the time. And I'd say just this week, just this week alone, from my experience, more than half of the drivability problems are not PCM or input sensor related. You know, it's pretty funny. I don't know how long you've been in the business, but I started my father's Flying A gas station working on Ford flathead V8s. And I remember the first time a car came with valve covers, and I thought, whoa, high tech, valve covers, you know. So I've been doing this a long, long, long time. And what I found out is very simply is that we probably had no problems years ago, because if a car's got a computer in it, then the computer is always the problem, right? So we didn't have computers, so we must have never had any problems, right? Well, you know, I think it's funny. You know, we got computers on cars, and we had something to blame that. All right? And one thing that I stress in all my seminars is that computers can do things we can, and we can do things a computer can't. A computer, if I said, I want you to put a vacuum gauge on your engine and study that every second you're driving a car, I don't know about you, I know I can't do that, right? But a computer can do that. But what a computer can't do, a computer can't kick common sense in. Yeah, we have all these new things with, you know, adaptive memories and all that stuff, but the bottom line is that a computer has a program, right? And it said, when you see this, do this. It didn't say, when you see this and it's a good signal. It says, when you see this, do this. So you have to start going into these things and really, really, really looking at what that input sensors are. Very rarely, hardly ever, will any customer come into your shop and complain about something that's an input. They're going to complain about an output. Right? So that means, well, the output's got to be bad, right? Or the computer's making it work and it shouldn't. Well, how about if we go look at the input? And I'm telling you, that's 75% of the time in that diagnostic shop, it's a lying input. It's what it always came down to. Right? That's what we're going to be looking at. So most common problems are associated with air-fuel ratio, and I'm telling you, it's going to get worse. Cars are running leaner and leaner and leaner. We've got winter fuel 365 days a year, and it's not going to go away. I love when they say, oh, it's okay. 2002 newer vehicles can handle it. I'm going to tell you what will happen and what's happening, and you're going to see for yourself. It's something I always hate doing a seminar and say, you can't fix it, and you can't fix this. But you got to be able to identify it. And you got to be able to tell if the things that are failing, the parts that fail, like the cop coils, are they really the problem, or are they the result of? Very simple what it comes down to, right? Examples of intake manifold vacuum leaks and fuel delivery issues like restricted fuel injectors and restricted fuel filters. Again, the run right people back there. Okay, carbon problems, absolutely positive. You got to deal with carbon problems. Here's the problem today, and we were talking about. I was talking to Bruce about it earlier, is that you can't be putting solvents down a lot of these brand new vehicles intake manifolds. So there are some times you're going to have to do carbon cleaning through the fuels, and other times maybe you still can't do it through the manifold. When you got plastic baffles and valves inside an intake manifold, right, and you start putting a real strong solvent through there, you decide where you want to be stuck at. And if you sit there and tell me, well, we don't work on the brand new cars, 1989 Toyota Celica had a variable intake runners in it. You know, correct me if I'm wrong, that'd be a 23-year-old car. So you can't be putting any type of cleaner, you know, in an intake that has anything like that. If you don't know, there's cars out there that have throttle plate. The throttle valve, throttle plate, whatever you want to call it, is 100% open when you start the car up. When you're idle, it's 100% open. When you're driving down the road, it's 100% open. When you deaccelerate, it's 100% open. The only reason that car has a throttle plate is to create enough of a low pressure for the PCV system to operate. How's the engine being controlled? Individual baffles at the intake stroke. So when you start putting solvents down, you've got to be careful today. Okay? The problem with these issues will affect the other circuits like the ignition that can cause partial or complete cylinder misfire. Unfortunately, we're led to believe ignition scopes are only good for finding open plug wires, foul plugs, and etc. Okay? I believe the root of the problem is that too much attention is given to a fire in KV and too little or no attention to the rest of the waveform. Okay? I would like to break down a waveform and give credit to the areas that we can understand actually looking at a problem, the effect of a problem. And remember what I said, you really won't have to look at the waveform once I explain exactly what happens in there. Okay? I understand it's becoming increasingly difficult to get an initial waveform due to the newer COPs. We will discuss it later. I like to show the analyzer on the primary side. All right, we get into this thing. I love this. You know, I say, look at this. I do a lot of work. I do a lot of consultant work for manufacturers. Right. So next year, this is the system that's going to be coming out of a couple of manufacturers right here. And what we have is a thing that's really weird. We have a primary and a secondary side of a coil here. Okay. And if you don't know the difference between the two, the one with the fewer windings is going to be a primary side, and then you have a secondary side, okay? And then very simply, you got battery voltage applied, and then you have a timer here that's going to time when you should do it. And then we got these new things called sparking plugs here, all right? And then very simply is that it's going to be the newest, greatest thing out there, right? Well, that's actually a 1928 Model T. You know, so we can sit there and say how ignition systems really, really differ and stuff. But correct me if I'm wrong, did they really, really change? All right, if you don't know this, the ignition system that you drove here today on, or yesterday when we got here, was actually designed in 1911. And I break them all down the same identical way. I don't know one out there that doesn't use primary, collapse the primary magnetic field and produces secondary. And when you break it down like that, I don't care what type of ignition system you have, they all basically do the same thing. Okay? Now here's what I'm going to do. I'm going to break this thing down. And I'll tell you what I did here. We don't all have this stuff. I decided, like anything else I've ever did in my life, I always try to go for the hardest one. If I can explain the hardest one and get everybody to understand it, doesn't that make sense that the other one's going to be easier? So if you're wondering, what am I doing with this stupid thing here called D? Okay, anybody remember the current limiting of the ATI, GMs and stuff? Well, if you don't know it, we still have that in a lot of cars today. But ATI, GM really brought that to a head, though. So we're going to break it down section by section right here. Okay? First of all, here's my waveform. We're going to understand very simply is that my dwell period is going to begin right here. So 1.5 million years ago, my points would have closed there, and my points would open up here. When you drove here today, or yesterday, whenever you drove here, your module energized here, and your module de-energized here. You know, it's pretty ironic, and I like to break things down to what they really are. We don't like voltage spikes on cars, right? We have clamping diodes and suppressing diodes all over the car. We don't like voltage spikes. This is the one voltage spike we want. That's really all it really is. We're building a strong magnetic field, and we're collapsing it. When we collapse it, we have a spike. Now, remember what I'm going to tell you. That's very important for this part. The spark going across your spark plug does not like the air-fuel ratio. And everybody knows that already. You've all pulled plugs out, soaking wet with fuel, and you had spark. It's the heat intensity of that spark that lights that air-fuel ratio. So we can have the spark. So there's a real good test out there. I'm sure nobody here has ever done it, where you want to find out if a Phillips head screwdriver is a good conductor. Right? Because that's the only reason I can think of ever sticking a screwdriver in the end of a spark plug wire. I'm sure you're just trying to find out if the screwdriver is made out of good metal or something. Because that really tells you nothing other than something is happening on there, the engine's spinning. Other than that, if you're going to say, oh, my ignition system's okay. And then, of course, I'm sure suddenly down in the Philadelphia area where they tell me, well, according to the color of that spark, you know, I know. Right? Or you can do Jim Linder's way also. Anybody Bubba's tips with Jim Linder? You ever hear of that? What you do, you grab a 1.25 inch common wrench, combo wrench, all right, and then you grab a secondary wire, and then how far the wrench goes when you grab the wire, that tells you the voltage level of it and stuff, all right? I think we can work a little more intelligently than that, though, okay? So now, what do you think that's waveform? Not a bad waveform, right? Now, by the way, I try to use as many different pieces of equipment I could. I won't say I'm using this, I'm using that. That's off the Vantage Pro, okay? What about that waveform? All right, can anybody figure out if I'm done this? I'll guarantee you'll be able to diagnose the vehicle off of that waveform, okay? Let me tell you what that waveform is. That's primary. So you don't need that big secondary scope. I've got my primary, I got 2 leads from a primary side onto a cop coil, all right? And I can diagnose this thing with no problem whatsoever. Now, remember when that waveform I showed you a while ago? And I said, George, why did you do this? I'm going to show you something right now, and I want you to keep looking at it every time I bring something up, okay? See this fire voltage right here going up, okay? And then it comes down, it comes across. Does anybody remember something different on that waveform? Remember how it jumped out early? It jumped out, went up, and it jumped out early. The second half of it was okay, though. So I'm going to give this away because I want everybody to really think about this during a lunch and when I show you what happens now. If you have that 90-degree turn right there, and I'll still call that a pretty close to a 90-degree turn, then you have no problem external of the combustion chamber. Okay? What you have is that if you got something on the right-hand side of the imaginary line, that's internal combustion chamber. And where do you see when you start looking at these things, like I talked about the lean air fuel ratios and the cloud injectors and everything else. So what's awesome, I think, about this is that everybody will be able to identify what cylinder the problem is and whether it's internal or external to the combustion chamber. McKenna used to, in order for me to get a lesson from McKenna, he had a Sunoco station in Trenton. After I was done all my work, I used to go up to his shop, and if he knew I was coming, he always used to bug a vehicle. I said, I'll get you with you in a minute. He said, go over to that vehicle over there, and it's got something wrong with it. So you say, something wrong with it. Go put it on the scope and tell me what it is. And what he did is, that means that before I got there, he did something to that vehicle. Okay? And if he saw me just unplugging stuff to see what he did, it wouldn't have been healthy at all for me. All right? But I go to him, I say, you got number 5 cylinder, you messed up, and you did it external combustion chamber. And I remember the last time he ever did it to me, he went over to number 5 cylinder, he put the spark plug wire off, and he took the 4 or 5 layers of cellophane tape that he put over the spark plug, took that off, and put it back on again. So what I'm going to show you is that accurate. It can actually show you what cylinder and internal, external combustion chamber. There's a lot of things that I've done in my life that work a lot of times. I'll say most of the times. This doesn't work most of the times. It has never failed me. Every time I've ever had to do this thing, I always can pinpoint internal, external combustion chamber, and obviously what cylinder it is. Okay? So now what we're going to do is we took it. I already ruined one myth now that we can't look at a vehicle, a cop coil. All right, there's a cop coil, and the end result is that you can look at it. Okay? Now I started off and I talked about primary and secondary. Okay, there's the same cylinder right there, and I'm primary and secondary on top of each other. And I don't know about you, but I bet anything, if not right now, you will be able to pinpoint things, whether it be the primary or the secondary side. And the neat part about it, when you do see a problem with the primary, like I said, it's going to go into the secondary. Don't blame the secondary until you go look at it. If I see a problem on my secondary side and I switch over to my primary, I see a beautiful primary, you know what? If it looks like a duck and walks like a duck, it's a duck. It's a secondary problem. But more than 50% of the time, I'm going to say more than 70% of the time, my secondary problems are in the primary. And especially today, with voltage drops and all that stuff, Doc was talking about if you're comfortable with Ohm's law, I'll tell you right now, no offense, if you're not comfortable with Ohm's law, get comfortable with it. Because voltage drop testing and Ohm's law, again, when I started in the industry, we had a 6-volt battery, and we had an AM radio and a starter. That was the electronics part of the cars. Now, I had to keep on changing with the times and stay up on it. Okay? If you're not comfortable with Ohm's law, if you're not comfortable with voltage drop testing, get comfortable with it. Okay? Now, that I talked about. Now, me earning a living, I do not look at that yellow trace. There's no need whatsoever for me to look at that yellow trace. What I'm actually have right there, and I'm not just coincidence, I guess, it's right here, mini amp probe. All right, I'm on the ground control of that coil right there, all right, with a mini amp probe. What a tough setup that is, 2 leads in your scope, and now you're actually seeing the work. Now look what I did here purposely. Look at the top of the waveform. Look at the top of the waveform, how it cuts off right there, okay? Look right here, what a coincidence, man. Right here, where this starts to go up, is even with that. And what is this down here? That's called current limited, which means basically you want to limit the amount of current because you're probably low RPM right now, and you're probably going to burn your circuit up if you don't limit it. And what would happen when you take this car and increase your RPM, you would take a picture of that, take both ends of that line right there and pull it. And what will happen is the hump will come out because you don't want to limit the current anymore. I don't know if it's the same in New York or not, but in Philadelphia, there's 360 degrees in a circle at 1,000 RPM. There's 360 degrees in a circle at 5,000 RPM. So you have to make and break the primary, right? And you have to build that strong magnetic field. That's why they put a lot of current in it, and I'll show you how they do that. But when you're low RPM, you got to be able to limit it, all right? Now, very simply, I just encourage everybody to really learn Ohm's law. Now, I'm going to break it for you now. Because if you go Monday morning to any car you want to bring in, a general rule of thumb, 0.5 to 3 ohms resistance is in the primary side of ignition systems. 0.5 to 3 ohms. And you know what, if I said, I want everybody to report back to me on Monday on the first car, you know what happened? You'd be probably 0.9 to 1.1. So by me saying 0.5 to 3, I'm really taking in everything. Most cars are approximately 1 ohm resistance on the primary side. Now, if you know anything about Ohm's law, and you're going to apply 14.6, 14.7 volts to a coil, that means you got 14.7, 14.6 amps. Well, what you're looking at right here, I'm set up at 100 millivolts equal an amp right here. And with this line right here comes out to, this is going to be probably about a little bit 4, and I'll show you later on, maybe 4 to 5.5 amps. That's a characteristic we're going to see. Every once in a while you'll see one up 9 amps or so, but most of them will be about 4 to 6 amps. Well, wait a minute then. Why would they build the circuit? Why would they build a circuit to build 14, 15 amps if we only need 5 or 6? Because what I told you already, if you build a circuit for 15 amps, how fast do you think you can get to 5 or 6? All right, you can get there awful fast, right? So the 360 degrees in a circle, that's why they do it that way. So what they do very simply is that line going up, that's called the current rampant right there going up, that very simply cuts it off. Now, you got 2 different types of ignition systems basically out there. You got one like this that'll have that cut off, and now when I hit the throttle, that's going to come out. And then maybe the first car you go on Monday and you do this, you're going to find out that it doesn't do that. What it does, it comes right to a point. And what you have on that vehicle, you have a ballast resistor circuit. And everybody in this room is probably, if you ever had a pleasure working the old Chryslers, you know all about ballast resistors, right? Well, there's 2 ways of controlling current. One is to limit it like this, or the other one is to drop the voltage, go into the primary. Remember, always remember this. Current follows voltage. If voltage goes down, current goes down. If voltage goes up, current goes up. So whether you got a ballast circuit, or you got a current limited circuit, or in some cases, you might hit one that has both. And the theory is very simple. At a high RPM, we'll still be able to get that system to fire. That's what it comes down to, all right? Now, and again, by the way, here's that U-scope, again.
Why would a system have volt methods?
Yeah, so I'll tell you what's going to be. That'll be your M3s, your M3 BMWs, and you know, performance vehicles. They muck around with a lot of them. You know, you think about it. A high-performance vehicle, they're still 360 degrees in a circle, right? So they have to do some stuff, and I'll talk about how they actually do that stuff. For the most part, you're going to get one or the other, but every once in a while, here's what's going to happen if I say this, and you go to first thing on Monday, go look at a car, and then your luck and my luck, you're going to get one that has a combination of thing. So, you know, I really don't care, as long as I understand it, though, okay? It's all about control, is what it's about, though, okay? Now, here's a perfect example I said to you. Is there's now I'm not a $299 scope, all right? And you put an amp probe on it, or you can go voltage. Now remember what I said also, look at that waveform. Look at the waveform here. See how it jumped out early right there? I guarantee you, well, by the time I'm done, you're going to realize what's going on there. I got a higher firing kV, all right, and I also got a higher spark kV. Okay, spark kV is extremely important, and that's where I'm going to lead this into. That's the part that nobody ever talked about. Remember I told you when that guy was getting off the stage? and I was getting on the stage, all right, that guy said two things up there. He said spark KV and imaginary line down to burn time. And nobody has ever taught about that before except McKenna. And what do you see how it's like I've had people that attend seminars, I've done this thing, and they said, my God, it's just so much easier now. If we got that, it's like nobody ever really looked at it, nobody ever talked about it. It's there, and it's pretty simple to see, all right? So the end result is that here's what I want to, a couple things I'm going to go over first. I talked about putting a puzzle together. And Doc was even talking about, is the problem really there, or is it, because of something else? Hopefully everybody in this room realizes that the computer doesn't take a guess of when to operate the fuel injectors. It doesn't guess. It knows when it's got to do it, okay? If you don't know, there's called syncing. And what you're looking at right there on the screen right now, that is a V6 engine. It's a 3800 General Motors engine. This is called, to me, I call, because I'm not going to listen to everybody's names, because I work on all kind of cars, like most of you do. All right, this is the alarm clock. The alarm clock is very simple. Go out in the parking lot right now. Your computer isn't doing anything. Right? It's not controlling anything. Why? Because there's no signal being sent into it. It's kind of like what Doc was saying. You got to make sure the thing's getting a signal first. So if you drive the alarm clock in, which in this case is the crank sensor, this V6 engine, if you take notice, I'm on one injector also. Well, if you count there, you can see every sixth one of these, that same injector works again. It's not magic. Right? Bottom line is almost every manufacturer is either going to use the rising edge or the falling edge of the waveform, and it's going to sync it. And why is that really important? You know how many times you've had a car already, and all of a sudden it just like stumbles and stuff? And if that's the rule, remember what I said, a computer can only do what it's told to do. So if the computer was told to hit that injector on a rising edge, what do you think would happen if that waveform dropped out for a second and came back again? That would be another rising edge, wouldn't it? And does anybody honestly sitting here right now think that that computer would know the difference between a good rising edge and a bad rising edge? Right? It is so common, it's unbelievable. And what I'll do a lot of times, I got fuel injection problems that's destroying the ignition. I'll take the crank sensor and I'll get this waveform up there and I'll tap it. Now, when you tell technicians to tap something, woo, everybody remembers the mass airflow sensor tap? With a 48-ounce hammer. If it wasn't bad before, it's bad now, right? So I use my finger or the screwdriver handle, and that wouldn't be my pry bar handle, right? And I just tap it. I'm looking for that any noise or problem with that. Make sense? And then all of a sudden, look at what I'm looking at. You're hitting the ignition, and it's going into 3 other circuits, actually. Okay? So what I want to do is, and this is the perfect way that we're going to stop for lunch, I want everybody, if you get nothing else, I want to teach you, right? There's not a car that you people have right now in a parking lot that we can't apply this to it. And this is what I did on all things wrong with it. I need to do some tests and drive down the funnel, okay? What I'm going to tell you right now is a perfect example that there's not a car that you drove here this won't work on. I'll use my own truck right now as an example. I have a cop ignition, a 6-cylinder with cop ignition. So I happen to have one A. A is where the primary receives its power from, but I have 6 Bs, because very simply is my modules inside a PCM, but I'm individually making a break in the path to ground, right? So I have 6 Bs. I also have 6 Cs because where does the secondary begin at the end of that cop? Now, if you have a vehicle like I'm going to show you in a minute, like ASC Composite Vehicle 1 was a 4-cylinder distributor vehicle, then that's completely different. But the bottom line is A, B, C, D. And if you think about it, why did McKenna lay this out like this? Because why wouldn't you go and check A first? Now, I'm not going to say you're always going to do that. It might be hard to do. But if I take my Phillips head screwdriver trick and I get nothing, okay, well, I got to go backwards at that point, okay? So there's not if you don't have A in the ignition system, you have no chance at all B, C, and D, right? So what I like about it, I don't know if anybody is a dealership here or not, but I'm independent. I've been independent my whole life. I was a troubleshooter for GM, but I was still independent. Okay? And the end result is that everything I'm telling you works on every kind of car. All you have to do is just tweak it. It's all about, I'm not flat rating. I'm speed diagnostics. I'm going to get to the problem fast, okay? So the bottom line is that always approach every vehicle this way. A is where the primary sees its power from. All right? B is where the primary is interrupted or switched at. If those two do their job correctly, then we should have C. Okay? If you have C, it should go to an end result, where it should go to the spark plug or the combustion chamber. All right? So I'm going to do an example, if everybody recognizes this thing. This is the old ASE Composite Vehicle 1. I'm just using this as an example. I'm going to blow it up, and there's the A, B, C, D right there. So I've got A, very simple, is going to feed the primary side right here. B is going to be my switch in here. C is going to be the output, and then I drew this here for D coming over. And this is very, very important because just like on the real world, like the cars you're going to work on next week, A might also be sharing with other things. And that's why that's really important. Make a voltage drop test. I can't begin to tell you how many times that my problem on my ignition system was actually due to a voltage drop from something else. Just always, always, always remember, electricity is lazy. It's always going to take the easiest path. And if it turns out it takes an easier path, then you're going to rob Peter to pay Paul. I don't have time to get into it, but I want to make a note right here, and I want you to put a note also. When you do not see, quote unquote, as everybody tells me, I don't have all the juice going to my primary. In today's world, you may not get all the juice to the primary. I spoke about it a little bit before the break. Like an M3 or an M5 BMW or an M Series Infiniti or a lot of other cars doing now. What they're doing, they're running the power supply through a resistor block. And the theory behind it is very simple, is that if you give all the voltage to begin with, in a high demand situation, you can't give it any more. But if you were to pull 3 or 4 volts from the primary, and then you get into, quote unquote, 5,000, 6,000 RPM, how can you possibly, with that 360 degrees in a circle still, how can you still bring a strong magnetic field? Is by using a ballast circuit and then returning some of the voltage back to it. I can't tell you how many times that I've been out and looked at a vehicle and someone has, quote unquote, pulled a new wire through, because they didn't see full voltage to the thing. My thing I say to everybody, let me see the wiring diagram you're working with. And the number one thing that's said to me when I say that is, it's the next thing I was going to do. Next thing I was going to do, pull a wiring diagram. We'll pull a wiring diagram. I know George is up here doing color coding wiring diagrams. I never, never, never approach a vehicle without having a wiring diagram from me. I want to see how the circuit works. I said it, and I'll say it every 5 minutes if I have to. I want to know my opponent. All the stuff I got on the board right now is the same for all vehicles, A, B, C, D. Right? But I got to see if they're shared with anything though too. So what you think might be an ignition problem might be very, very simple, the effect of something else, which I'm going to be showing you. Okay? So now, here's very simple. I talk a lot about ignition timing and stuff. Right? And the bottom line is that, I don't know how you are, but I'm a learner. I learn very easily by hands-on. And I don't need anybody. I left so many seminars. And I say to myself, wow, man, that guy was smart, man. I didn't learn anything, but boy, was he smart, That's not what I want. I want it very simple, everybody to be able to apply everything I'm showing you right now. And I find from talking to a lot of technicians that everybody seems to have a different variation of what ignition timing actually is. All right? And it's a very simple concept if you think about bicycle pedals. All right? Very simple is that if I'm going to put my effort down on my bicycle pedals, all right, I'm not going to wait till they go over the top and then down to the 3 o'clock position. All right, so when we talk about advance in time, and I always joke about it, I said, when I become president of the United States, which might be a little while yet, if they dig up my past and stuff, but they call it advance in timing. Advance in timing to me is really retardant timing. What I mean by that is if you look at this circle right here, when we set base timing on a vehicle, all right, we're in here about 8 to 10 degrees before top dead center. And that, right away, that doesn't make sense. I don't want to put my effort down on my pedal right there. But it takes a couple of milliseconds for the explosion to actually happen. So by at idle, having 8 to 10 degrees before top dead center, the explosion is going to happen right here. So it doesn't make sense, everybody, if your bicycle pedals are going faster, right, you're going to have to think about putting the effort down over the top sooner. And what happens with ignition timing, when we quote-unquote advance timing, we bring the timing down here with 25, 30, 34, 42 degrees timing so that the explosion still happens there. And this might sound pretty simple, but I'll tell you what, I can't begin to tell you how many times on the board right now, on that screen right now, is what I got called out for. because people just didn't realize this vehicle is running around in base time and quote unquote it seems to idle okay. You know, they said, well, you know, I can't loosen a distributor. There is no distributor. And I was out on a vehicle about a week ago with a DIS system, and the thing was running at a base time of 18 degrees. It's because the computer thought it saw something. And then very simple, okay, how can we have lack of power? Because very simple, we got the wrong time, we're putting the effort down on the pedals. So it's something I encourage everybody to put a scan tool on a vehicle, all right, and take a good vehicle out for a ride and really, really watch that. And again, what happens a lot of times, like years ago, we started to get metallic noises in an engine, and we disconnect the knock sensor, right? Today, you can't do that because for the most part, these computers, what they do, they have a mode of operation where they check, it's called an intrusive test. And they do something momentarily to set off a knock sensor. And if it doesn't work right, it's going to set a code. I can't tell you how many times. I just had recently a plumber's truck. His pipes rolling around in the truck was setting off his knock sensor, pulling his timing. So this dealership's been working on the thing now for about 3 weeks, and they're arguing back and forth. They can't find anything. He's mad. There he takes his days. He's going back and forth, back and forth. What he was doing, he was borrowing another truck and taking all his crap out of his new truck, putting in his old truck and going out and working, and then they leave the truck, and the end result is I finally said, no, something's different here. And the bottom line, I made him put all his stuff back, and I said, I'm not even going to help you. Because if I put it back in the wrong spot, I want you to put all your stuff back in. He put the stuff back in the truck, the pipes rolling around, clinging around, set off the knock sensor. It happens a whole lot more than people think. Right about now, in the next month or so, I'm going to receive all kind of phone calls about lack of power from landscapers. Right? They're towing a trailer. Unless the hitch is attached to rubber or something, it's going to make a metallic noises, isn't it? And these things are pretty sensitive today, and it starts putting off the knock sensors. So you got to be aware that maybe you really don't have a real ignition problem. You have a computer that thinks it's seeing something. All right, very important. All right. Now, here's what I'm going to do. When I'm coming in, we're going to do this relatively fast. I want to get to a couple of things that are really, really important. A lot of things everybody should know, like we're A. A is nothing more than, that's your primary side right there, and your primary voltage comes in, so your 14 volts or whatever it is comes in, and then what happens, it pulls down. It pulls down. Now pay attention to that though. And everybody says, oh my God, I looked at one, if you take notice what I showed you before lunch, when a real circuit pulls down, usually there's a lot of noise in there. You know, and I show it to people, oh, you know what that is? That's point bounce. And I don't think so. You know, I'll be over home, my points would be bouncing around and stuff now. What that is, that's supposed to get ruffled in there, or as Doc said, what he's called squiggly lines. We get the squiggly lines, they're supposed to be there. What that is, that's called a muffet. And what it does, it basically cushions that grounding right there. But you know what you want to do? You want to get used to if it's normal or not. Some of them have a discrete 90 degree and some of them don't. So you got to know what good is. I can't say mechanics show me all the time. Look at good, look at good, look at good. When you finally see bad, it sticks out like a sore thumb at that point. But most times your problem here is going to be very, very basic, like anything else. If I said pull past the ground on anything, a light bulb or something, it's a discrete pull down. You don't want to see a thing slanting down. You don't want to see pulling back up again. I can't tell you how many times that I've seen this pull down right here and then almost immediately come back again. That must be a current limiter. They're not going to limit current right away. No system does that. What that is, that's a weak ground. You know, I tell people all the time, I say, you know, I bench press 200 pounds. Piece of cake. Okay, bench press 200 pounds while we're having a 45-minute lunch and hold it there. You know, bench pressing 200 pounds is one thing. Holding it is a different thing. Pulling ground is one thing. Holding ground is a different thing. And it's a very common. I see it rise, and I say, oh, that must be current limited. Current limit is not going to, if you have it in that system, it's not going to be until about 2/3 or 3/4 of the way in. Not right away. Never, never. Get used to good. Remember what I said? The weak primary is, you know, always, always, always. You got a secondary problem, you know, look at your primary. All right. There's been a thing out there for a million years, and they say is for every 1 volt loss on a primary, you have the potential of losing up to 10,000 volts on a secondary. I did not say 1 volt on a primary, you lose 10,000 volts on a secondary. You're probably not going to have 10,000 volts to begin with. But if you get in a demand situation, and if you don't notice, you're seeing it already, when the car gets in demand is when everything starts to really react. All right, so you need to have the ability to be able to build it if you need it. Okay? Now remember what I said though also, a lot of new cars today aren't pulling full voltage to that primary. They're pulling 3 volts or so, and then they're giving it back to it. But you will be able to see that in a wiring diagram. There's going to be a ballast circuit in it. Okay? 5.0 Mustangs. It's common, very common. You go to the 6 pins on a module, the TFI module. You know, pip, spout, start, run. Start, run, right? That's the ballast circuit. What you do is very simply, if you're going to pull voltage on your primary anyway, 3 volts or so, what did the very first slide I showed you, second slide I showed you, what happens to voltage when you crank it over? It goes down again, right? So if you're going to pull through a resistor and then also pull from a starter, you're not going to get it started. So why do they have a start and run? They bypass the ballast circuit doing start. I bet everybody in this room has had one of those vehicles. You turn the key, it starts up, let go of the key, and it dies. Start it up, let go of the key, it dies. What you have, you got a problem in ignition on the ballast. Now, when it starts going bad, you get a voltage drop. That's when you get the drivability issues, right? The B, like I said, the primary is being pulled down right there. C is the dwell time. That's when your coil is saturated, okay? Now, this is where we got to understand that I decided to put the one with the current limit in there. They might not have that. There might be a straight line, or there might be the current limit. But bottom line is, you're going to have one of those two, and I don't care what it is, when it pulls down, you want that to stay down. When you have a current limit, it's going to be a very, very, very discrete looking signal pulling up on an angle like that. Right? It's not going to have noise in it. It's a discrete signal. But the dead giveaway, and I encourage everybody, it's actually easier to do, is you use something like that milliamp probe, and you go around with that milliamp probe precisely when you see that current limiting. On a milliamp probe, you're going to see the current also at that point hit the level. And by the way, a couple of people just to tell you, just to clarify this for you, a lot of people say, well, I never heard of PDI and stuff. Well, let me tell you, PDI has been making milliamp probes and amp probes longer than anybody I know other than Fluke, but they've been making it for every other company. So everybody has seen PDI equipment. Guarantee you've all seen PDI equipment. Just had somebody else's name on it. So the bottom line is what PDI made a decision to do was start producing their own. All right, so it's actually, I have a $500 milliamp probe, and I'll put it up against that milliamp probe, and if I showed you 2 waveforms, and I said which one is better, I'm going to guarantee you that one is going to look better than my $500. Well, why am I so stupid to buy a $500 one? Because when I started doing this stuff, there was only one probe out there. I didn't have a choice. Okay, that's a really, really good probe and easy to hook up. You know, one other thing, I have a couple questions, so I don't have to answer everybody's question. That's banana jack. There are banana jack ends on there. There is another one, a BNC. Don't get the one BNC. Get the one banana jack. That way you can get a BNC, the banana jack adapter, and then you can use it on any piece of equipment. All right? So if you buy the one at BNC, you really are kind of stuck to that BNC at that point in time. You can't get an adapter the other way. You really don't want to go the other way, though. Okay? Go with all those banana jack ends and then do the conversion over as far as to BNC.
Point B is dwell limiter?
Okay, yeah, well, I got point C is the dwell. I haven't got that. Point C is from the point of what's going to happen now. And here's another thing very important about that. Sometimes that's going to change, and sometimes it's not going to change. Remember when I told you about the current? I told you that you're going to get up, and I showed you that straight line. If you get that, you're usually going to get a varying dwell. If you get a straight point coming down, that means you got a ballast, and that won't change. The degrees will be the same degrees all the time. The difference is by increasing or decreasing voltage, you increase and decrease current at that point too. And I got a couple as we get down to this thing, lower into the thing, I'm going to start showing you what happens when you see a bad one, and we'll see that, okay? Okay. Here's a perfect example. There's current over time of a coil. And when I explained to you before the break, everybody can realize that if I take a line and I come up, straight up here, it doesn't make sense that this line here and this line here are eventually going to meet. Well, I'm going to guarantee where they're going to meet at. They're going to meet at about 14 amps because I got about 1 ohm resistance and 14.7 volts, and that's Ohm's law. But what they do very simply, this particular one right here, I'm set up at 100 millivolts acre on amp, right? And I'm up to 200 millivolts per division. So there's 1, 2, 3, 4, so almost up to 5. This is a couple type of vehicles out there, especially some imported vehicles, will run as high as about 9 amps. So I'm running about 9 amps right here. But I've got 1 ohm resistance, right? Actually, this one here is 0.8 ohms resistance and 14.7 volts. So that's why that one will go so much higher up there. So if you continue with that, that's what it will look like. So you have to know the rest of the story because very simple is that they have to build it very fast, so they do it this way. Now, I'm sure everybody in this room, either you or somebody you know, has read some high-performance magazine, right, and said, here's what you got to do. You want more power? You get a high-performance ignition system, okay? Now, besides the fact that they're going to paint it yellow, blue, or pink, or whatever, right, and they're going to tell you it's going to give you a neck brace with it, a bonus. If you call within 3 minutes, you're going to get a neck brace because it's got so much power and all that stuff. Well, it's very cool, and you need to understand this. What they actually do is, if you got 1 ohm resistance in the primary side of the coil, what they do is they bring that down to like 0.7 ohms resistance. Okay? At 0.7 ohms resistance, everybody in front of me right now could be able to look at that and figure out what's going to happen. What's going to happen, the angle of the ramp is going to move this way, right? Because it's going to go much faster, because if you put 0.7 ohms resistance, instead of 14 amps, you're going to get to 17, 18, 19 amps down at that point, right? So what happens is you get to the same current you need, that same 5 or 6 amps again, but you're going to get it much faster. That's quote-unquote performance. And the reason why I point that out, I don't want to make this a performance class, but the reason why I point that out, 3 guesses what happens when you start getting voltage drop in the circuit. When you don't get the right amount of voltage. Remember I said current follows voltage. So now all of a sudden what you're going to take notice of is the angle of the ramp's going to go this way. So now I'm still going to get there and say, no, you're wrong, because I measured the current here with my amp meter, and I'm still getting the same amount of current. Well, you might be getting the same amount of current, but what would happen if this current here went up to right about here? How long do you have it? All right, that's a weak current. And that's the vehicle when you get into a demand situation, you see it fall on its face. And now a lot of people say, well, how do we know which is which? Like everything else almost you ever do with a scope, comparison reader. So what do I have right now? I got 1 coil operating, okay? If anybody's ever read any book and seen pictures like this in a training manual, more than likely what you saw with it, you saw a 6-cylinder wave spark, and you see 3 coils. And then the next photo shows 2 close to each other, 1 missing, 2 close to each other, 1 missing, right? That's mine. All right, every time I say it, I know how he gave it to, and that's a perfect example of a bad coil. But what I like about it, I have another picture, no one ever seems to want to print it, and that's just all 3 are there, but 2 of them have an angle like this, and one's got one a whole lot more pointed. And what that was that vehicle getting into it, getting a very, very weak primary, which is causing a secondary to break down. So comparison, read. The key thing here is to think about it. If you're going to go with voltage over time and look at coils operating, how many coils can you get to the ground? A lot of them plug right into the modules, right? You can't get to the ground. But the neat part about current's on the power and the ground side. So when you go to the power feed of a coil pack, all right, or the power feed of 6 cops, you can see all of them. All you got to do is change your time base and put them on, and they got just like an old parade pattern. You got them all lined up. Now you're doing a perfect comparison reader. I tell you, it's not anywhere near as difficult as people think. You just got to get started looking at good ones. That's all. Okay. Now we're going to do what I did here is I took the same thing again just to back it up. Now there's another stop. There's the other stop I was referring to. Take notice, there is nothing there. It goes up to a point and stops. This is the circuit that has a ballast circuit in it now. So what's going to happen is high RPM, low RPM, what's going to happen, it's always going to look the same. Okay? But the difference is that if I actually put a meter on it, the voltage is going to change on the thing because it's a ballast circuit. But what I have here, I've got primary. This is, I think, a really good picture here. This is primary waveform. This is that stuff that everybody tells me that you can't get anymore. Thank God I've been getting it for a long time before people tell me you can't get it. All right? It's actually, I think it's easier. It's easier to get the primary side of the waveform. So there's my primary axle working right there, all right? And here's my thing. So take notice here, like grab this one here. There's the operation I said, and I hope you took my word for it. If you didn't, I'm backing it up right now. Right here, when that went down, that's the beginning of the dwell. That's when you start building your saturation. Well, look how it lined it up perfect with that coil right there, with that ramping right there. So there's no doubt about it what's actually going on there. And what happens also, what I pointed out to you, sometimes you're going to see a little bit of noise right here, but that's supposed to be there. That's a cushion. And how I know on this car that's okay, because look at the current. The current's fine. Now, I don't like saying this, but I'm going to put it out there anyway, because it's something that it's good, but you can't carve in a rock. is when you start to get a misfire in a cylinder, on the current side, on the back end of it, right here, when it goes up, it comes down, right here, you get a lot of noise. And when I've been doing a lot of cars, I'm good at this, and my students, like Dave, is even better at it, messing cars up. Okay? And the end result is when you do, you cause a problem. How many times in classes I say, come on guys, let's go, we're going to go mess cars up. And what I mean by that, we're going to cause a misfire and watch what happens during a misfire. You know, it's okay not to destroy a vehicle, but here's what would happen if. So if I cause bad connections, cause a misfire, you pick it up in a coil right there, on the back side of it right here, you pick it up. Now remember what I told you. Now everybody tells me you can't use primary waveform, you know, for analysis. That primary waveform, I don't know about you, that's crystal clear. All right, and the nice part about it, if I want to change my time base and make that to 50 or 100 milliseconds, I'll put more on there. All right, that's a parade pattern. Now, it's a very, very simple thing because it's a simple fact that I can get the current on all the cylinders now. But what I'm doing on this thing here, I'm on one cylinder, just look at the same cylinder firing over and over again. Okay? Okay, now look again what I said about the current limit. Somebody just asked me, you were asking about the current limit. There you go right there. What you said was that, does that line up? Well, here's the current limiter right here and here. Now, if I were to hit the throttle on this vehicle, what's going to happen on this vehicle, the dwell is going to increase, right? And what's going to happen here is that this angle here is going to come over toward here. I'm going to lose the current limiter. All right, the further this goes, this is going to move over also, and then it's all going to move together. So the reason why is that's about 6 degrees at idle of dwell right there. You go to get about 20 degrees of dwell at 2,000 RPM. When you start raising the RPM, you still have the same amount of degrees to do the job in. So now you don't want to limit current anymore. Now, little thing to throw in, you might want to put this down. It's a very, very common thing I see all the time, is that when you buy, and I'm sure there's some quality, quote-unquote, white box stuff out there, almost every time that I look at a vehicle that say that it was bad, it didn't run, and the guy puts a new module in, and now it runs, but it just doesn't seem to have the same amount of power, I can't begin to tell you how many times what I find a white box module has a fixed dwell on it. So these GM ones, for instance, they were 6 degrees of dwell at idle, and up to 20 degrees dwell at 2,000 RPM. After that, they didn't extend anymore. I can't begin to tell you how many of the Corvettes and stuff I looked at 13 degrees dwell no matter what. All right, and what it was, it ran. It didn't run before it runs now, but it's not going to run with the same quality. So you want to get used to, is this a dwell that varies, or do I have a ballast in it? And you'll find that's how they save money. That's the most expensive part of that module to build in. So they can get the car to run, but now we're sitting there trying to, I would like to say, pull your hair out, but I don't do that. Okay? But the end result is that you're saying, why isn't it running like it's supposed to, though? Okay? Now what I'm doing is I'm moving this. I want to show you time-wise. You can see how they line up perfect, right? Look right here, all right? And look where it starts and look where it starts there. I'd like to bring cursors up just for that reason. It's not me showing you. I think it's happening right there also.
You were just talking about a few seconds ago. How did you correct that problem?
That 13 degrees and stuff, a quality module. Yeah, there's nothing I can do about that. Or, you know what I do? I've done it. I'm going to tell you more than not. At least I told the shop or the owner of the vehicle, here's what it is. And you make the decision. You know, you want to leave your $35 module in there. You want to put a $95 module in there. The car's still going to run, but the reason why it doesn't have the power, I've given the answer. I'll tell you right now, a lot of cars, 25% of the cars that I pinpoint the problem, it doesn't get fixed. They just at least they know. What it is now. So, so at least I'm very, very important about this whole thing I'm doing. I can't say, I think maybe perhaps it's here, this is it. But I have to be able to know what good is in order to say that, though.
Most of the time it's like generic versus OEM, right?
Yeah. And it's not always, some of the aftermarket stuff is just as good, if not better. But when there's a reason that something is $95, something's $30. And it's not, the printing on the box doesn't cost $65. Yeah. So here's what I talk about current limited. And a lot of people think that went away with the GM HEI. It didn't go away. A lot of cars have. A lot of cars current limited. How they show it to you in the waveform is what you want to get used to. Okay? So here we go now. My one piece of rope. This is what I really want to accomplish this afternoon. everybody talks about the firing kV and the burn time. I talked about it first thing, okay, that one piece of rope, all right? If it's harder to fire the cylinder, your firing kV is going to increase, okay? What I do all the time with my students, they love to see me do this because they're hoping I'm going to have a heart attack and fall over. Say, I got a tile floor in my classroom, okay? And I say, guys, here's what I'm going to do. You know, I'm 150 years old, but I'm going to see if I can broad jump, 2 tiles. And the end result is that they, yeah, go for it, Miss Moore, I hope I'll fall over, they get the rest of the day off, well, I could probably still do it. I don't do it, but I can probably still do that, right? And I say, okay, what do you think? How about 5? 5, you're going to die. I say to them, seriously, and I say to you, if I was able to broad jump 2 tiles, if I get a ghost of a chance whatsoever of jumping 5 tiles, what do you think I'm going to have to do? I'm going to go take a run and start, right? I'm going to back up, okay? And if I happen to make that, right, how about 12, right? I probably have to go back to Route 84 or something, right? Take a run and start. Maybe I'll go to the top of that mountain up there or come running down, right? I have to take a bigger run and start. That's why I really don't like to do what I have on the board right now. What I like to do all the time when I talk about this, I like to watch you, want you to see me drawing it. You know why? Because I'm going to put a line up. I'm going to put a line up and a line down. So anytime the ignition system feels that it's going to be hard to jump the gap of the spark plug is this G right here. This is the burn time. If it feels it needs a lot more energy to do that, what it's going to do, it's going to take a run and start. That's why it's important you understand that's not one line. That's a line up and a line down. And they want to see, I'd say this all the time to my students. I said, okay, 6-cylinder vehicle out there, 40,000 gap on the spark plugs. I want one student to go out to the shop right now, the rest of us in the classroom. I want you to take all plugs out. I want you to gap 4 of 40,000s, put them back in. I want you to gap 1 of 20,000s and 1 of 60,000s. Okay? And if whoever I send out in that shop, he's going to tell me what cylinder they did at 20, which one he did at 60. If he doesn't, he's going to fail. It's going to be so obvious, it's unbelievable. So the 1 of 20,000s, that fire line is going to be lower than all the rest of them. But guess what else is going to be at the end? The burn time is going to be longer. Okay? If the one he did at 60,000, that's going to have the highest firing kV. Okay? So it's harder to fire the cylinder. Now, I'm not really worried about worn plugs. Well, we all got that. I'm worried about all the other conditions. No matter what, it's going to do the same thing. So now let's go with something where we're running too lean. Let's go with something like my students, and I'm sure some people here and some people that you know, they can't live until they put platinum plugs in their car. I can't begin to tell you how many times somebody comes in to me and says, my car is kind of okay, but when I get into it, man, it really falls on its face. And I go and I put a meter on the thing, and I look at the burn time, because I don't look at the firing kV, and the burn time is 2.6. Everybody remember this morning what I said? 10 to 15. All right, 2.4, 2.45, 2.6. What do you think the firing kV is? See, here's what you really need to understand about this. The ignition system, as far as I'm concerned, this is my own opinion, is the dumbest circuit on the car. It really doesn't know what it's there for. It doesn't know what it does. If it make it jump a gap, all right, and the heat intensity of that spark when it's jumping that gap, like the air-fuel ratio, I look at the ignition system, secondary, and all I think of is an old horse. It's been in the riding stable for 17 years now, and you take it out, and it's the slowest thing you ever had in your life going this direction. You turn it around, it's going to run back. Let's go home. All it wants to do is go home again, back in that stall, right? Your ignition system just wants to go home. And where's home? The coil. But if it happens to jump a gap and enough heat's there, it's going to weigh off the air-fuel ratio. It really doesn't care whether it does that or not. So that's why I said that gap at 20,000s, it's going to do that. It's not going to fire the cylinder, though, because very simple, the energy. So that firing kV is going to come way down. Burn time is going to be extended. That's why I said, and I say it again and again and again, don't worry about firing kV. Worry about, very simply, is what's the burn time. And remember I said the newer cars. And I said also, I can take everything I have on the slides here and throw it out and just talk about this week. All right. I saw a burn time this week at 0.6, 0.7. All right. Almost literally all week. I bet anything, I was back in Philadelphia right now, I bet anything that I get nowhere near that. Because very simply is that it was very hot, especially about 2 in the afternoon or so, and then the end result is you get all kind of conditions. Now I want you to say this, I can go again, I can go all day just on the newer system. Let me tell you on my own truck. My own truck is a returnless fuel vehicle, okay? Well, what's that mean? I go, oh, that's that new kind of system. Well, let's see. When I first started in the industry, we had returnless too. It was called carburation. All right? All the fuel left the tank and didn't come back again. So now we went to return system. Now we're back to returnless again. Well, let me explain something. And do me a favor. Don't believe me. Do this. Check it out yourself. Go to any car you want returnless fuel, which is probably going to be Monday or Tuesday. You're going to be no problem. And you might have to put a level on it. Don't look at your eyes. Put a level on it. Put a little level on the fuel rail. And almost every returnless, what's going to happen, they tilt up as they go closer toward the front of the engine. They tilt slightly. Okay? You know, common sense. Please do me a favor. Just listen to yourself, common sense. My truck sits for approximately 6 hours a day at the post-secondary school I teach at before I hit the road and do everything else. 6 hours a day, so at about 2 o'clock in the afternoon, in the heat of the day, after it's been sitting there for 6 hours, that fuel's been sitting in the fuel rail. Okay? What's been happening to the fuel in the fuel rail? It's been vaporizing. It's volatile. The volatility of gasoline is how easy it changes to a vapor. If you don't know why we add alcohol to gasoline, that's why. I can't tell you how many times I've done a seminar and I went to go get some rubbing alcohol. I'm not going to use like Jameson's or Town Merdew. You know, that's too expensive and stuff. I'm going to use some rubbing alcohol and I'll put a little in my palm of my hand. I'll go, hey, look at it. No, wait, I'll be back in a minute. And I try running as fast as I can never go back because the volatility. Everybody's had gasoline in their hand and it instantly vaporizes, right? Well, alcohol is what makes it vaporize. And alcohol alone is very volatile. Now we're going to E10 fuel. It's hot and it's sitting still. And it's tilted up. I don't have to tell you the rest of the story, do I? What's happening is the front of the rail has got a lot more vapor in it right now. So every time I start my truck up, like on Tuesday and Wednesday this week, in a matter of a couple minutes, I set off a PO 301. Come on, think. I was like, wait a minute, you got that wrong, man. You meant say, right? No, it's 301. I'm talking about a fuel problem. What's a 301? That's an ignition problem, right? Does everybody know see, I always say, you know, it's so easy to play the game when you know the rules of the game. Like I had 3 garages at one time, 2 general repair shops and my diagnostic shop. My one general shop was in a very, very, very high-end area. And people say, oh man, we don't want to work on those cars. Right? Those people, they want their cars fixed right and stuff, you know. I tell people all the time, you know what, those cars are easier to fix. You know why? They had more input, more sensors and everything else. Let me remember this. Remember what I'm going to tell you right now. The rules of OB2 state, not only you have to know what cylinder is misfiring, but you've got to know what's causing the misfire, what's fuel related or it's ignition related. Everybody know? My truck, 201 or 301. Cylinder number 1, misfire, fuel related or ignition related, right? Everybody hear what I explained though? It was my fuel that's causing my problem. Why is it sitting off a 301? Because what they do is the manufacturer is allowed to look at one or the other. And if the one he looks at looks okay, he blames the other one. Okay? Now visualize that your computer is watching the ground side of my fuel injectors. What's it saying? It's saying switching, isn't it? It happens to be dumping vapors in there though. But it doesn't know that. What it's doing is it sees it switching. If it sees the injector switching, it makes an assumption the injector's okay, so it must be the cop coil. Now what's happening, kind of funny, eventually it will be the cop coil. Because what's going to happen is that my system is running so lean that it's actually destroying the cop coil. I joke about it. I'm going to start rotating my cop coils. I'm going to put number 1 in the back there for a while because very simply, and without saying what manufacturers have this major problem, you might have figured out which one I was talking about, and they were talking about how bad our cop coils are. All right? The cop coils are the effect of the problem. They're not the problem. So what's happening is we're running so lean today anyway, all right? What's another manufacturer that's known out there all over the place for being lean? The cleanest cars, Nissan. Does everybody realize right now, Nissan has technical service bulletins out there. They have cop coils melting in the head. It is so bad what they're doing. They're given authorization, a warranty to replace the head rather than spend all the time trying to get all the blob out. All right? And the funny part about it, I was brought in on one of these jobs about 6 months ago, and it's done it again since then, the same vehicle. Now, you want to see something, run a vehicle, a cop coil, that's what you know is a pretty fair lean anyway, all right? And take that cop coil out and see how long you can hold on to it. I mean, that's like the old days, just the spark plug itself. These cop coils are literally burning up right now. You know, take a cop coil and lay it down on a bench and stand away from about 2 foot and look at the blue ring around when it's molded together. Just same as you were putting a torch across the thing. And you all know that lean's hot anyway. Everybody knows that. You know, I started two most favorite classes I'm asked to do all the time is 5-gas analyzing and ignition. All right, 5-gas analyzing, cut and dry. You know what I do? Very simple. I walk out on the darn stage with a set of cutting torches. All right? I put it on, turn it acetylene only. I'm standing there holding this like a Statue of Liberty. All right? If I'm ever going to stick my finger in a flame, I'm going to stick my finger in this flame. Everybody understands that, don't you? But if I add the oxygen, you stick your finger in that flame. So what happens when I make this flame leaner and leaner and leaner? Now I can start cutting the legs off the chair and stuff, right? Transfer that information you already have in your head into the combustion chamber now. Make sense? All right? That's always, oh no, when it's rich, boy, that's really hot. No, it's not. You know, go put your torch and acetylene on only and go down and try to cut a leg on your chair. You'll be there until the next TST big event. You know, you maybe a bubble of paint. All right? Lean causes heat. So that's what's happening in these combustion chambers now. All right? Here's that rope. All right? And by the way, you'll see this in a lot of books. This is McKenna. This is McKenna. McKenna's the one who started this stuff. He talks about it. I swear he could walk around on Sunday afternoon, coming out of church, and he had this piece of rope on him at all times. Always telling people, you know, this stuff here. Remember this. So don't worry about the firing KV. Worry about the burn time. One more time, it's very important. 1.0 to 1.5 milliseconds, okay? The newer the car, 1.0 to 1.2. Because you know the firing KV is going to go higher now because it's running leaner. Okay? You don't want more than 1.5 and you don't want under 1.0. Okay? Okay, now, let's get into the meat of this thing. That one piece of rope you just showed, see the 2 circles I have there? All right, there it is right there. And I'll tell you what I don't like, even though I just did myself. You saw my waveform, how beautiful that looked? Everybody says the same thing, and I'm going to say it also. You want to really study details in a waveform. And you want to see nice, you know, 90-degree turns and all that stuff. No, you don't really want to. See this right here at the end? This is the end of the rope. Here's the part of the rope. Here it goes. See how that goes up right there? I can't tell how many thousands of hours I've seen wasted. People go, what's that about? What's that about? What's that about? Everything I'm going to show you now, remember this. All right, voltage over time. All right, from bottom to top is voltage, and left to right is time. And that's important because if I got a hump right there, right, I said a linear fuel ratio is harder to fire. You need higher voltage, right? Isn't most of the fuel, hopefully isn't most of the fuel burnt by the time you get to the end? So everybody says, oh, you want to see a nice straight line. I'll tell you right now, if you have a straight line, go find out why your cylinder is running too rich. You want to see it kick up. But I'll show you, well, how bad and stuff. Hopefully you can say, it's Doc, well, what's the variation? Well, I'll show you. When I know I got in your head, I'll show you bad ones then. You can learn to compare it. Okay? Okay, now, this is the one at Harding. Has anybody ever used Spark KV? I'm sure you heard of it. Has anybody ever really used it? What is it? What's Spark KV?
The firing voltage of that cylinder. We used to use an old test, that we can measure that.
Okay.
There's the ionization voltage, but then there's the actual sustained voltage.
Okay. Well, it's usually, and everybody describes it different. That's why I asked that. Almost everybody describes it different. But honestly, I don't even care about description. It's such a powerful thing that's unbelievable. The Spark KV is the amount of voltage between the very bottom right here, and where it jumps out at. Okay? And you know darn well, everybody in this room, the amount of times you heard anything about that, you can put in a thimble. And when this is the single biggest thing I get feedback from people who attend the seminar, I'm talking about this. They have no idea in the world how powerful that was. I've got literally thousands of emails. And my God, man, I'm cutting my time way down on this thing now, you know? And I think that's kind of funny because it's not really that new. But it's something that now I realize I had the privilege of studying under somebody that really knew what he was talking about, this stuff, and showed me something, okay? Now, everybody remember, as I go through this now, everybody remember, no matter what the reason is, firing KV is going to go up because it's harder to fire the cylinder, okay? But with a spark KV, that's the one you're going to learn to really, really watch. If the spark KV changes or doesn't change, there's a dead giveaway of it, where the problem is actually at, okay? What that voltage actually is for the ignition system, what it needs to maintain that burn across the plug. If it turns out that the firing KV goes so high, it builds up energy so high, it has the ability, enough strength at that point to jump out early. If it's high resistance external combustion chamber. Now watch. First of all, this I like to tell you, again, I said this earlier and I'll say it one more time. I'm cheap. I must be. Because I don't throw things out. Okay? Anybody remember that old Snap-on Vantage? Okay? The MT2400. I bet a lot of people have it. All right? Remember that KV probe that hung on the back of the thing? Now, does anybody have that? Did you buy that? Did you buy it or did it come with it? Okay? Anybody who had the MT2400 already, because it didn't come out for a couple years after the 2400 came out. And then what happened was they came out with this KV adapter for it, right? That was going to show secondary patterns. So all the Snap-on people went out and told their guys, "Oh man, you want to see secondary? Well, you go give me another $1,000. And boy, you hang this right on the back, you can go see secondary." Well, see the picture right there? All right. First of all, that's me causing a problem, so you're going to get two straight lines. Now, I don't want to get crude about this, but a lot of the Snap-on dealers didn't like that the thing was so big, because what the techs wanted to do with that thing after 1 week and give it back to the Snap-on guy in a different cavity, right? Because it didn't show, it said anything. I paid $1,000. I'm not seeing any secondary. They want to take the thing and jam it the guy's butt. $1,000, man, and stuff, right? So if you ever saw one, there happens to be a decent manual. It describes it. And why do you think I said it's a decent manual? Because I wrote it. Because the bottom line, Snap-on came to me, we need help. I said, what do you need help for? They said, if we have to buy back all these modules, we're in trouble. I said, you know what it does, right? We can't describe it. So what it is, and listen, I'm telling this for a reason, because you can find these things out there. So when I'm talking about, you don't need a $50,000, $60,000, $70,000 scope. You need an understanding of this circuit, all right, and something to tell you. Now listen very carefully. A KV Pro that went on the back of that MT2400, what it did is, it showed you a representation of the firing KV. It showed you a representation of the burn time. It showed you a representation of the spark KV. And nobody used the spark KV one because they didn't know enough about it anyway. Okay, so here's what I'm doing right now. Remember I talked about, I said this rope, right? Okay, that's a 6-cylinder vehicle. I'm on a coil wire, and I unplugged one wire. Don't just let's look at it and see what I just said. What I said was very hard to fire. Right? What happened to the firing KV when I did that? It went through the roof, right? What happened to burn time? Right? So look at that. So what it's showing you right there is 5 of the 6. You know, they're somewhat close. You got the little variation there and stuff like that. But they're somewhat close, right? But look at this one. This one here is going to 22.6. And you can see that's 0, that's 30. So you know that's going to be under 15 right there, right? And this went to 22.6 right there at the same time. Look at this, 0.85. So now you don't have to listen to me anymore. There it is right there. So I caused the problem to show how that unit can actually work. Everybody with me so far? Okay, now when people say, well, wait a minute though, you know, how do you know what cylinder it is? Remember me talking about the funnel? I don't care, to be real honest, I don't care what cylinder it is right now. I know I'm going to stay in this funnel now, don't I? It's an ignition problem. That's the main thing. I didn't have a hobby, I had a business. I want to find out what funnel the problem is. As soon as I see this, I know that I got a problem in the ignition. Now what I can do, I can take another lead that had this side with it, and I can trigger off of cylinder number 1. Now if I happen to know what the firing order is, I'll be able to tell very simple, right? But that's not it. I don't care. I know it's an ignition problem. That's all I care about right now, okay? Now wait a minute. Let me go here, and that's the gap of the plug and everything, right? But imagine, I'm going to show you now the spark KV. The spark keeper is going to do the same thing with a line. Watch what happens there. Go. What do you do? Go. Can we go back to that?
What that would look like if you unplugged the injector?
Does what? Say it again.
I was wondering what that would look like if you unplugged the fuel injector.
Well, it's almost the same thing, because no matter anything's going to make that. That's a good point, and it won't go as bad. I'm causing a major problem. I'm going to show you waveforms of both, but yeah, almost the same is going to happen. So, and it's kind of neat you say that. How much did I pay you to say that? It's like, it's kind of weird what you're saying, because you know what I would know? I would know I got a problem on that engine, right? That's all I would know. But when you follow me through, by the time I show you the actual waveform, not only would you know now that problem, but now you would know that it's internal or external combustion chamber, whether it's an injector cloud or something like that. That's where the power of seeing the actual waveform. This is a representation of it. But you know what? This thing is fast and easy. Literally a pickup on a coil wire. That's it. But if I want to get more detail and find out what it is, my key thing I'm trying to get in your head right now is general test. Once I know I'm in that funnel, I'm staying in that funnel. All right? Here's something that you got to think about. Anybody give me a waste spark? Waste spark is going to fire once on the compression, the other one on exhaust, right? Right? You've been talking a little bit about the lunch about it and stuff like. What's normal firing voltage? What's kind of firing kV when it's on the exhaust? Any idea? What do you know about that? Right?
Lower kV.
Okay. Well, how much? What's low? 10? 1,000? What's low?
Maybe 12.
Okay. Okay. Everybody listen to me very carefully. And this is cool. And this is going to help you a lot help a lot of different things. There's a thing called law of ionization. And I didn't make it up. You know, it was here before we got here. Law of ionization. And look at this very carefully. It takes approximately 80 volts to push energy through 1,000th of gap at sea level. What's a plug usually gapped at? 40? Right? What's going to take 80 times 40 is 3,200. Anybody say it takes about 3,000 volts to fire an empty hole? Okay? You know how many times I've seen this ignition system using 6,000, 7,000 to fire the waste? And I talked to them, you need to get back there and get with them run rate kits. You got so much carbon buildup in there that it's doing the compression's high even on the exhaust stroke. And it's basically causing the firing voltage to increase. So now what's going to happen now if that isn't fixed? The ignition is going to burn up. And then when we replace the ignition, then you're going to walk around and say, oh man, fix that one, huh? Don't worry about it, it's coming back again. You know, it's coming back again. So the main thing I'm trying to get in your head today, when you see a problem, are you actually really looking at the problem, or you're looking at the result of the problem? I guarantee it right now, you start starting them next week, you start looking at waste sparks, you're going to see waste spark 4,000, 5,000, 6,000 volts firing the exhaust. And what that is very simple, you got some kind of condition going on there where the compression is going up higher. All right, do that, because localization doesn't, it's not like import or domestic. Say, localization is a localization. Cut and dry and simple. Right? And you can apply this. And now think about how kind of voltage you get when it's under compression. All right? Well, I said it's sea level. So you can actually figure out, literally, probably within about 100 volts where you actually should be when you're under compression also. All right? And I said it's harder to fire a vehicle, high compression, and linear fuel ratio, right? Now you know why. All right? So your high performance ignition really isn't something that you need more of. You need to be able to do the same under compression, that's all. And also proves another point that Philip said screwdriver testing. Now, I'm going to take a guess. It's not under compression. You're not putting that screwdriver under compression, are you? So usually you're verifying that you got like 3,000 volts. Well, that's going to do a lot. All right? You see where I'm going here? Now, what's the next best thing then? You know, get one of them simulate test spark plugs. You know, an ATI tester or something. That's going to make it jump 250,000. That's the same as like 40,000 under pressure then. You know, you can't sit there and say, it's not this, unless you're rock solid proof that it's not that. And in my mobile diagnostic business, like I know a couple other people probably have that kind of business also, you know, comeback's really bad for you. Think about me, or think about like John and Elle. You gotta give her someplace else. I gotta say, this is the problem. I didn't say, I think maybe this is the problem. And very simple, when I see something, I see ignition system burn up, I got to know if that's really the problem or it's a result of. How about my own truck? Well, when, not if, when my cop coil burns up, when I put a new cop coil in it, did I fix it? I didn't fix it. Right? I still have that same problem where it's running lean. I can imagine, remember I said earlier, how if I start putting E15 in my truck? No? It's probably going to cost me more, and I'm going to take my cop coils out in a heartbeat. I'm going to like every other day rotate my cop coils or something. You know, it's something that I hate sitting there saying you can't fix it. But you know what? You can't fix this. You got to know what it's from, though. All right. So very simple. What I just said. If you take 45 thousandths gap, all right, and it's not under compression, all right, and work at that law of ionization, that comes out to 3,600 volts. And you don't want to see 5,000 or 6,000 when you're on exhaust stroke. Simple as that. So now you can see that how you're getting that 12 or 20 kV because you're under compression at that point then. Again, I don't worry about the firing kV, I worry about that burn time though. All right? Okay, now look, here's a perfect example. Here's another piece of equipment. It's in the back of everybody's shop, facing the wall. It holds at least 5 coffee cups, right? And no one ever uses it because it's an old piece of junk. That's a snap-on counselor. All right, I don't know about you. If you follow what I said so far, look what you got going on there. I've got one cylinder. The firing kV is a whole lot lower than the rest of them. And if you really look close enough, now this is a parade pattern. I don't like looking at parade pattern for time things. And that's another thing. If anybody in this room was taught secondary analyzing, I'm positive whoever taught you either a thing called a raster display pattern, right, parade pattern. They taught you one of them. Hardly anybody ever really learns both of them. They're using a raster pattern and display pattern. And the reason why is we want to learn both is because one is fantastic to look at for voltage things, and one's fantastic to look at for time things. This is a parade or display pattern. What I can tell is that all the firing KVs are how uneven they are. Okay? But look at that fifth one. And if you look real close, even though you don't want to look at it for this thing, look at the amount of time, burn time here, look burn time there, and look at that one right there. All right? Now this is ironic because this is an internal, external to the combustion chamber, which I'm going to talk about later. This is a burn exhaust valve. Okay? What it is one of my students' vehicles, his mom's vehicle, all right, and what he's got a burn exhaust valve, and actually the valve is actually in a couple training magazines now, the picture of it, because it looks like someone took a torch and cut part of the seat right out of the thing. And then very simply I said to my students, okay, look what we got going there. We did a cylinder leak down test. Right? You can see the problem, air coming out, the exhaust and everything else. I said, okay, there we are. Well, we got the problem now, right? And this is the point I'm trying to make here. This problem actually took out other things now. Well, what was happening, before it did that? What was happening before that? How did the exhaust valve burn to begin with? Right? Because of the restricted fuel injector that was in that cylinder. So there's a perfect example. We would have taken the cylinder head off, right, and replaced the valve and everything, we would have got another chance at it. We would have been really good at it after 3 or 4 times of doing it, because the injector was actually really the problem with this thing. So ironically, if you take notice how it's also jumping out, it's also jumping out a little bit earlier there, that's because the secondary ignition wire was also burned up on that thing, besides the exhaust valve. So when I get in, I'm going to show you more in detail which side and which side. This is a combo problem, though. Okay? And that proves something else also. All it wants to do is go home. Remember me talking about broad jumping? How easy it is to jump this now, because basically you're not getting any real compression in the cylinder because the exhaust valve is half the seat is missing on the thing. So now very simply is the ignition system wants to write me a thank you note. It can go home easier. That's it. All right. Here's that MT2400 again. And look what I'm doing. I'm going to show you something. They call it power kV. All right, now again, I don't care what one company wants to call this, one company wants to call that. This is the firing kV, okay? See this top of this line on the one we're actually looking at? Well, see this line here? This line is basically, if I say to somebody, is to draw a dot here, a dot here, a dot here, a dot there, a dot there, and connect the dots. That's what you have there. So when Snap-on guys went out and say, oh, you're going to see a secondary pattern here now, and they look and they get that line like that, they say, no, it's not a secondary pattern. But you know what? Look at it. It's pretty darn good for a fast, easy hookup. If I saw that thing and it looked like an O2 sensor, Well, we got a major problem with it, right? It's okay to get that kind of noise in it. Overall, they're basically okay. You know what I would now know about this particular vehicle? Whatever problem I have, it's not ignition. Now I'm going to take another one. I'm going to look at the other ones also. And you go look at the burn, or the burn KV on the thing, or burn time, and the spark KV. Now look here, I'm on a secondary pattern here. Basically the same thing I just showed here, right? What I'm doing is I'm showing an actual one here. And again, I'm on a primary. So I love everybody. You can't look at primary and get a good reading. Thank God I was doing it for a long time before somebody told me I couldn't do that. I mean, look at it. That's a beautiful reading. What I now know about this particular car, whatever it is, here's my dwell, here's my module energizing, here's my current ramping, here's my firing KV, here's my burn time. I'm slanted up a little bit right here, and I never got this. So I never. What is this here? Wait, what's that for?
It's a leftover energy being dissipated back into
Leftover energy? What's that thing? Ah, man, look at that. The ignition system is stupid, man. They build more than needed. Isn't that dumb? Please, 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 everybody, please, listen to me. This is something hard. Anybody knows anything all about, I'm telling you, start looking at this. This is very, very, very important. All right? That's called kinetic co-oscillation. First of all, it should be called capacitor co-oscillation today, right? But it's called kinetic co-oscillation. If I put a potato in a microwave for 10 minutes, and I take it out, all right, and I throw it back there to Pete, right? And Pete's going, oh man, it's hot. He's going to throw it back at me. And I'm going to throw it back at Pete. I don't want to hold on to it. He doesn't want to hold on. So we're going to go back and forth. Is it going to get hotter? It's going to cooler, isn't it? Okay? Here's the deal. Years ago, they used to build about 3,000 volts extra on every firing. So if the ignition system felt it needed 12,000 volts to fire, it would build 15. If it thought it needed 15, it built 18. It builds about 3,000 volts left over. Not because it's stupid. Because what happens is, when the dwell completes, it starts to build. And it doesn't know that you might be pulling up behind somebody, going a little bit slower, and maybe you might want to pass that person. And when I do this, I pass somebody, am I going to go lean or rich? Lean it first, and then rich. Air and fuel don't move at the same velocity. You open the throttle blade, right? And the throttle blade, a rush of air coming in. And remember how many times have I said it so far today? A linear fuel ratio and high compression is hard to fire. Now I'm telling you, you've all had the problem I'm going to describe to you right now. I see it all the time. You got a coil starting to go. The coil can only build 16,000 volts. It needs 14,000 volts to fire normally. It's going to run perfect most of the time, except for in a demand situation. And I don't know, nobody here would do this, but so first of all, at least 4 computers can be thrown at it. You always go to at least 4 before you make sure the determination is not that, right? And then you put at least 3 sets of injectors in and 2 fuel pumps, right? And then you figure out, you know what, this is an age-old problem. Now listen to me very carefully. Newer cars, cop, okay, you're not going to see 3,000 volts left over. You're going to see about 1,500 now. And you're not going to be able to measure, but we are going to look at, years and years and years, what we said 4 or 5 oscillations. Now everybody had their own determination what oscillation was. You come up with your own. You're going to see about half what you usually saw for 2 reasons. One is that you got a cop ignition now. Everybody's responsible for their own. They can build it faster. And electronic throttle control. So when you go like this now, the computer's going, nah. Now I used to get away with that before. You know, we're going to open it to speed I want to open now. Right? That throttle blade is not going to open like that now, right? So they don't need that 3,000 volts left over now. Okay? But this is very, very, very common problem out there. So you're going to build extra voltage, right, if you can. And if you can't, that's the car that's going to react, you know, negatively only sometime under certain conditions, quote unquote intermittent. That's another course I do. There is no such thing as an intermittent. I'm allowed to say that. I've worked on enough. There is no intermittence. And everybody in this room, you had an intermittent problem. Once you found what it was, I bet you can make it do it again and again and again, right? You just had to find a combination, right? And this is a perfect example of that combination. So you're looking at here, you're trying to get the whole waveform and figure out the whole waveform itself, okay? So here's that spark KV. This is that cheap piece of equipment a lot of you have already, and look what it had on it already. Hey, 0, 5 kV, this one here is about 1.5 K. So what I told you is that reading between the low line going up and the 90-degree turn, that's spark kV, right? Watch what happens here. Everybody, there's the whole thing. There's the spark kV, the burn time, the firing kV, okay? Now, what you've got again, I got the spark kV and I got a firing kV, that's what they call the burn time, right? Or the firing kV. And this is up here, so we got 9,500. We're running, remember I said it's about 3,000 volts usually. This has got 3,500 right here, but it's pretty even. Now, I'm going to show you what happens. That's good. Now look what happens when a problem pops up. All right? Look at all my babbling so far today. That's second from the top cylinder. Which one do you think's got the highest firing kV? That one, right? Because look at the burn time. Okay? So what did I do there? Well, very simple what I did. I increased the spark plug gap by 20 thousandths on that plug. Okay, what I'm trying to do, I'm trying to back up what I'm telling you. Here's what happens. So if I didn't do it, and you got a worn plug, or anything else under the circumstance, it's going to do the same thing. Okay? Now here's the most powerful part. This is the thing the guy said when he was getting off the stage and I'm walking on, and he talked about imaginary line down the middle of the burn time. Okay? I want everybody to do this. Now here's a perfect example. That unit I talked about on an MT2400, you know, you get good. And like you said, well, is it this or is that? I'm gonna get some good ideas. But I can see the actual waveform, even on the primary. Put an imaginary line down the center of the burn time. Now listen, anything to the left is external to the combustion chamber. When I say anything other than good is to the external combustion chamber. Anything to the right is internal combustion chamber. All right, watch what happens now. I'm going to start, look at my one over here. Okay, here's my 12 right here, and here's my firing kV. See how that thing jumped out right there? Okay, I'm positive that's external combustion chamber. You know why? I did it. When you get a fuel filter, you got little plastic caps on the end so you keep the dirt out while it's in storage. I took one of those caps off the fuel filter, I took the secondary spark plug wire off, and I put that cap on it and put the spark plug wire. I caused external resistance that jumped out early right there. Take notice of the second half. Put the imaginary line down there. Look at the second half. The second half is straightening itself out. Okay, now watch how this, we're going to go to an actual situation. You people are going to do a diagnostics. And we see how simple it is, and I'm going to guarantee you, it's going to work that easy also in your shop. All right? Here's your imaginary line. What I did here, I did my fake one. I made it jump out, external resistance. Okay? Here, I did dramatic here. What I did, I unplugged the secondary ignition wire. Remember what I did before on the other one? You saw the line go up and line go down, okay? Well, now you can tell, not only do I have the same thing, my firing kV is high, my burn time is shortened, but my spark kV changed, which you couldn't see before. I'm positive it's external combustion chamber now. Now, that's dramatic. I'll show you what I mean by that. We're going to go a little easier than that. So.
The old point, distributor cap when the rotors used to burn away.
All the things we used to see, you know, the old cap and rotors burning up, it's all external combustion chamber. But I'm telling you now, this is now, I'm only 29, but about 45 years I've been using this now. And I've never hasn't been correct, internal, external combustion chamber. All right? And I'm telling you, it's really cool when now, not only you know the cylinder, but you got a head start on the whole thing right now by taking internal, external cylinder too.
So number 5 would have a problem too.
Oh yeah, believe me, there's a couple other, and you know what, I love you said that, because you know, I do like Jerry sometimes, I do like ASE tests and all that stuff. You know what I hate about ASE tests? There's always a problem. But when I work on cars, there's usually more than a problem, right? There's usually 4 problems. I got to figure out which one it is. So what you're saying is there's a lot of problems on cars, and that's why I like to use real vehicles. Because you know, when I worked on the vehicles, I stayed concentrating on what the car was there for. But I also looked, hey, by the way, besides that, you got another underlying condition here going also. And you're going to see a lot of that in the ones coming up and stuff. So.
2 and 5 are the companion cylinders?
Yeah, you can't. That's not as clear. I'm just doing this one here to show you something. And remember what I'm going to tell you also. Does anybody have a motor? Anybody have a motorsport Advantage Pro? Do you have the secondary, the SAI 2000 kit, that piece of junk kit that everybody complains about? Okay, it is a pain. That doesn't give a very good pattern. But watch what I'm going to do with that kit, and I'll show you. Once you understand what I'm showing you, you can take that kit to a different level right now. And by the way, if you don't have it, you can probably get one for next to nothing for somebody because they can't stand it because it, quote unquote, shows a lousy pattern. Watch what I'm going to do with that kit. Okay? All right, now, before I even say one thing, okay, I can't even get the top of the firing KV there. The top of the firing KV is going, now by again though, it's primary. I'm not even on second, I'm primary. Look at the firing KV, it's way up there someplace. All right, so I know I got a high firing KV. My burn time is short, and where is that? Look, put that imaginary line down the middle. All right, here again, that problem is absolutely positive, 1000% external combustion chamber. Remember when I started off and I showed you that waveform that George Mention put on his little U-scope, and I said, why did you put a, like, how did you know that? You know, and it turned out that he didn't realize that they just took a picture of a waveform. Okay, what did I do? I did it. I'm good at this stuff, by the way. I can fix them. I can mess them up too. I'm really good at doing both. What did I do here with 2 cylinders? Right? I'm trying to show everybody that there is no problem whatsoever on those 2 cylinders in the combustion chamber right now. What I've got, I got it jumping out. So look at the 4 of them. Look at the 2. What I did actually, I took the inline spark testers. Okay? Well, I have an adjustable one. Right? Isn't that external? Isn't that a resistance? What I'm doing, I'm adding resistance outside the combustion chamber. Right? I don't know about you, that's sticking out like a sore thumb right there though. I can't see the firing KV. Why? Because I'm in a raster pattern. And raster is good for looking at time things, but lousy for looking at voltage things. Okay? I don't need to look at the firing KV right now. It's sticking out like a sore thumb in that burn time right there. Right? The 2 are completely different than the other 4. Right? A lot of times you get these carbon tracks. Remember, electricity is lazy. Now, would that be a problem, internal or external combustion chamber? And you want to hear something? Now, listen to me very carefully. People don't even think about this. All right, your car. Forget about your customer's car. Your car. When your spark plug, if you have spark plug wires on your vehicle, do you have short or long boots? And most people don't know. And most people think it really doesn't matter. It makes a big difference. Because from the factory, believe me, they put a lot of time into this. Because electricity is lazy. If you put a short boot in there, there's a big difference on a ceramic, the porcelain, for getting down to the metal. Isn't the end result, what's going to happen to the plug normally? It's going to fire down here, and it's going to go back up here and go off into the head, right? So this is the end result anyway, right? So electricity is going, hey guys, look, instead of going through in that compression and that resistor plug, hey, come right down the side here. I can't begin to tell you how many times somebody comes in a misfire in a vehicle. When did it happen? Someone during lunch talked about talking to customers. I do an 8-hour course on interviewing customers. All right? You can't, nobody in this room can handle 22 to 28 problem cars a day, every day, with a 3-week wait without positively having a really good way of interviewing people. Those people know more about the problem than you do. Don't let them walk away. Interview the customer, interview the customer. You know what I get all the time with something like this? The problem started 2 weeks ago. What happened 2 weeks ago? What you have done? Nothing. And then all of a sudden I start looking at the car, visual inspection, and it looks like the alignment adjustments were off. Oh yeah, well I had alignment, They can see what it 2 weeks. I had alignment about 2 weeks ago, just about when it started, right? Well, how about if somebody's doing alignment and for whatever reason, the guard on the front wheel well, has not been replaced. Not that any technician would ever not put everything back. Okay? And now all of a sudden, when it rains and you turn the wheel and all the water comes in and hits the porcelain, that was a problem with Cadillacs for years and years and years. Right? Now what happens is electricity is lazy, the water's a conductor, and it goes right down. So it's intermittent. No, it's not intermittent. It happens every time it's wet. Right? So you're going to see that. Now the other car manufacturer might put a long boot on it. That way they put a long boot on it, they got a lot less chance of having that problem. What's the problem with a long boot though? Now you're almost like a guided path down to that metal. So some manufacturers don't like the long boots, some don't like the short boots. Okay? But electricity is lazy. Now, this is a big problem right now. Cop coils. Every time you pull a cop coil out, look at them. I'm telling you right now, look at them. About halfway down, look, and you can see the marks there. I see lightning strikes. Because when that goes down, that cop coil is going into that hole there, there's metal there. If that system's running lean and it's got ethanol fuel in it, it's 2 in the afternoon, you're taking that firing kV and you're going to 30, 32, 34,000. I'm seeing it on a regular basis right now. And guess what? 30,000 volts can damn near go any place it wants to go. All right? And what happens is most cop coils, if you look at them very closely, in the middle of the cop coil is the mold where the two halves are put together. And it's literally jumping out there. And once it starts doing that, that becomes an easier path at that point. What I'm doing now, when I'm just seeing the beginning of it, I'm taking the cop coils out, wiping them down, a little dialogue compound on there. I'm breaking the track. I'm trying to get the thing to go where it's supposed to go. I'm not fixing the problem. I'm telling the customer that. I'm not fixing it. I'm putting a Band-Aid on it. All right? Because the bottom line is we're creating a condition of high firing kV. Well, what could I do? I don't want to increase the gap. I don't want to drop the gap either. You know, I used to do all kinds, like years ago, General Motors put a 65, 80,000 gap in the plugs because the carburetor runs so lean. What did it do? Someone just, it burnt the cap in the rotors right out. You know, you can't offset it though too much either. Yep.
I had this understanding, and I believe it's true, that these were also caused with spark plug sockets that were too narrow and the ratchets and the extensions would touch the
Yeah, I mean, we could do a 4-hour, yeah.
And usually once that happens, you've got a track in your boot you can't clean. You've got to wire also.
Yep, and that's what happens. A lot of the length of the plugs today, there's so many factors and stuff. And literally, we could do a 4-hour seminar on just the different plugs. I think I'd rather go back to that first couple slides I had with the sparking plugs. We don't have to worry about that crap anymore and stuff. But you're absolutely right. The type of material they're made out of, the type of point on the end of the thing. We got all these crazy points today and stuff. You know, they're all doing it for a reason. Remember I said a spark doesn't like the air fuel ratio, heat intensity does? What do you see with spark plugs today? That point, right? That's funnel it down. It's a crack. You know, the plugs, they don't last that long, right? But the bottom line is they do get that energy to make it burn. So, you know, it's like this. It's one big balancing act, what you're saying and everything. Right? And we are damaging a lot of plugs also, the longer ones with the wrong socket on it and stuff like that too. Okay, look here. Now I'm talking about this side now. Internal of the combustion chamber. Okay? Okay? You're not allowed to read the bottom there. Don't read the bottom, right? Look at the plug. Look at it. Everybody see the 90 degree? Look what I got. Firing kV's up. Okay? Firing kV's going up. And then coming out basically, if I hide this right here, man, you can't get much better than that. Okay? But the firing kV's up, right? But where I have the spark kV is the same as the other ones. That's the cool part about it. If the firing kV is high, okay, but the spark kV is the same as the other cylinders, all right, it's not external combustion chamber. It's inside the combustion chamber. There's a partially restricted ejector right there. And by the way, that is that one I showed you, the burn exhaust valve. All right, after we took care of everything, that was the partially clogged injector that would cause that problem right there. All right. Okay. Now here's actually I installed one of the scopes they have over here, the PDA. PDA, that's the scope there, the Master Tech one. All right, I don't care what you want to use. I don't care, right? But look here. Everybody from across the room can actually see there's something going on there. And what is it? This is the same spark kV, spark kV, spark kV. They're all about the same. But look at that there. This is absolutely positive. And again, you got some type of a problem that's causing it to run too lean. It's an intake. So when I say internal external combustion chamber, you got to watch how you do that. Because this vacuum leak, what I mean by that is it's not high resistance electronically outside with a wire or the plug or something like that. This is causing an internal problem with that cylinder right there, that leak is going to cause a lean condition in the combustion chamber. Make sense? All right. This is one now also. This is a big problem now. Go ahead.
Just one question before you get too far off. Carbon tracking, will that get rid of the carbon tracking prior to the cylinder? Will it have no oscillation?
Yeah, and we'll go into that. Okay. This is, please, everybody say, we don't need a number. Listen very carefully. I'm going to say back 1999. You're going to take notice just when you leave here. At that first stop sign, first traffic light you get to, take notice how many flex fuel vehicles you're around. Flex fuel vehicles are all over the place. People, well, I don't care. They're burning the same gas as I'm burning and stuff. Here's a very, 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 very important thing. I have been seeing the last 2 to 3 years, I am sick of this, to be honest with you. I'm seeing so much of this, it's unbelievable. And what you got to know is that, do you realize that one of the things that got the automotive manufacturers in a lot of trouble, what they almost went out, is they did too much monkeying with their money, too much research and development independently. Let somebody else do it, right? Like a company like Delphi, right? Delphi, if you don't know, Delphi does tons and tons and tons of research, and basically, I've always joked, they got like a supermarket. So if you want a fancy intake manifold, go to Delphi and go down aisle 4 and see what kind of intake manifolds they have, all right? Delphi makes about 85% of all the flex fuel sensors. That is Delphi's sensor right there, all right? And what these things do is they tell the alcohol content as the fuel is going up to the engine. Now, if you don't notice, most of the new cars today don't do that anymore. Now they're using the O2 sensor, and the fact that they see that the fuel went up, and basically what happens at that point, the car's got to run a little bit bad for a while before it sees it. This theory here was we saw the fuel increase. We're going to look very carefully at the frequency or the hertz of this sensor. And I would suggest that you remember where this slide is here, because this is not, take notice, I have nothing out there about what kind of car. This is almost every flex fuel vehicle. If it's in line, if the sensor's in line, they use this system here. It could be on the firewall. It could be underneath the, where your driver sits, okay? A 50 hertz reading is 0 alcohol. 150 hertz reading is 100% alcohol. So what I usually see, if I got ethanol fuel in an E10, I'm going to see 60 hertz signal. Okay, now here's a perfect example. You got to get up on electrical, man. You got to put your meter on that. You got to look at this, okay? And 10 days ago or so, I had a phone call from Missouri, all right? And I got this, someone told me to talk to you, listen out, I got this and this. And he got a computer dumping fuel like crazy. He's tried everything, 4 computers in a car, and this, and this, and this, and it's a 2002 Chrysler minivan. I said, put a scan tool on it. He said, I already did. I said, look, you called me, you asked for help. I'm telling you what to do. I'm not charging you. Do what I'm telling you, I'm going to hang up. All right, I don't have time for the games. Put a scan tool on it, key on engine off. All right, I got it. Okay, now, scroll through the PIDs. It said, one of them says alcohol percent. What's it say? He goes, hold, does it say that? What's it say? It says 67%. Right? These sensors are going bad. So now, again, like I said a couple times so far, computers are really smart, but they're also dumb. So if you don't notice, all right, very simple, I said it before, alcohol is about 2.5 times more oxygen in it than gasoline. So now this computer thinks there's 67% oxygen in there, or alcohol in there. So what's it doing? It's dumping fuel like crazy. All right? Very simple. I said to him, now listen very carefully. I'm a lover. I said, I'm not going to say, okay, throw it in, or we'll put the part in and see. I can prove it. How can you prove this? Very simple. Unplug it. I got a sensor simulator. I bet a lot of you people have a sensor simulator. You have my demo boards. I drove a 60 hertz signal. I told him to drive a 60 hertz signal in there. Drive a 60 hertz signal in there. What's the computer now think? It's E10. Pulls the pulse width way back, starts it up, the sun comes out, the birds shine, the birds singing, and the sun shine, everything's beautiful again. Because it's now listening to the truth. I'm telling you, there's so many jobs like that. The computer's not the fault. The computer's doing what it's told to do. Simple, right? Here we go. Love this one. I don't know how many people get involved with current rampant of injectors, okay? Now, everybody, if you don't understand what you're looking at, again, I don't look at volts over time, okay? Everybody says the same thing. If I put a picture up there of a volts over time of injector, you see it pulled down, and you say, what is this area here? That's the pulse width of the injector. Okay, give me the definition of that. Oh, that's when it's operating and dumping fuel. No, it's not. This is the pulse width of the injector right here. From here to here is the pulse width of the injector on this vehicle, 4.0 milliseconds. All right? That right there, that's when the pintle moves. So from here to here, and there's a big argument out there whether any fuel is actually coming back. I really don't care. Even if a little fuel is coming out, I'm not going to lose sleep over it. Basically, the pintle did move right there. Visualize that I take somebody and I push somebody, right? I take Rich. I push Rich, and I push Rich, and I push him. The 4th time I push him, he moves backwards. If I'm pushing, he moves backwards. Isn't it easier for me if he's moving backwards? What's happened, you're building current, you're building current, you're building current, you finally build enough current that the pintle finally moves, right? And that's me, that dimple there, that's why the dimple's there, because it's actually moving. And by the way, has anybody ever seen like adjustable fuel pressure regulator? If you adjust the pressure regulator, you get, you know, richer and this and this, right? There's two things that move a pedal. One I just described here, the strength of the magnetic field. And the other thing is when the fuel comes in, it goes down and hits a cone down there. And it hits the cone and causes a reaction, a vortex, and helps pull it. So if you didn't change the resistance of the injector but raise the fuel pressure by 5 psi, it's going to fly open. Okay? Let's talk about setting the lift wrong. And let's talk about pinching off the return lines then and driving the fuel pressure 2 times higher than it should go. That's what happened to this stuff, right? Now, this is about ignition waveforms, but you see my point I'm showing you right now? It doesn't stay in ignition. So now I'm going to show you a problem. One of my students, this is his vehicle, Mr. Martin, got a problem. My car's got no power. And blah, blah, blah. Well, I can't imagine that. You put all that high-performance crap on there, man. You know, my God, would break your neck and stuff, right? So anyway, I went, and I took a picture of it, and I said to him, I want you to drive home, and I want you to sing to yourself. What do you mean? I want you to sing to yourself. I said, you're probably a pretty good singer, right? If you're not, who cares? You're the only one in the car. Sing to yourself. And tomorrow morning, we'll bring the car and we'll take a look at it. Well, but no, sing to yourself. Why did I say that? Because when I popped the hood in the vehicle, I saw a battery cable on the hood of the car. It looked like 7 people carried over. You know? And the bottom line is that's a red flag. I want to know what the hell that thing's powering up, okay? But I don't have time to play the game right now. Just sing to yourself on the way home, okay? Here's his audio system. All right? When you ever hear that I don't know, yeah, get the same song in New York that we have in Philadelphia. It's called Boom, 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 Boom. Right? And the flip side is Boom, 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 Boom. All right? Well, there's the Boom, 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 Boom there, right there. All right? So if you listen to me and understand how the pintle actually opens up, there's the boom booming right there. So when you turn the radio off and stop drawing 162 amps, right? I said, maybe now we have enough current to pull the injector. Now, what do you think? Well, why am I bringing this into my ignition? What do you think this is doing to the ignition system? They're burning it up like you can't believe. All right? Unbelievable. So when I sit there and say, you can't just do ignition waveforms, what this is all about, and I said, you don't have to go buy a scope. Know what's happening in the combustion chamber here. All right? This thing is literally burning the thing right up. And the funny part about it, I brought him in the next day to this class, into the shop, and I said, okay, we had the picture I just showed you there, you know, the good one. And I said, put the radio on. And he said, no, come on, man, put the radio on. All right, it goes click, you know, boom, boom. I said, no. You went past me the other day. I was standing in the parking lot, all right? And I was doing this. And it wasn't me moving. You were making the earth move. Well, you're like, no, I'm not giving you a leg to do it very long, but I want to hear that beautiful song. And he cranked that up, and that's what I got right there. Make sense now? So you've got to investigate. Either you really look at the problem or you look at the result of the problem, right? Carbon. That's what I love. I think it's kind of weird. I could talk about carbon and run right back. You got to get that stuff clean. Do you realize very simply what's going to happen, especially in the morning? Everybody in this room has heard a customer say, start, stall, start, stall, start, stall, start, kind of run a little more, start, run a little bit, and then it seems to be okay. You know how many times I've gone away to a seminar, I've stopped and got a couple little charcoal briquettes and took them to this class, because no one ever seen them. They all got barbecue grills now, you know, propane. And I take the briquette and I smash them and stuff, and if I put water in there, what happens in no time? It's gone, right? Well, we never, I don't know why, we never seem to get that, okay? So what I told them, I said, I went into class one day and I said, well, because we usually talk, see, my students, they have all eight categories already. They've had engine performance for 8 weeks. And then I teach a separate class called Advanced Engine Performance. The problems I worked on the day before is basically what we talk about. I said, oh, God, wait, we're going to see today, man. I had a car yesterday, you know, and it's so cool. I thought, you know what, I took the engine apart last night just for you guys. You got to see this, man. You see what I took out of this car, man. It had I'll find it now. There. I said, look at this intake valve. Hey, man, I said, when the injectors are shooting this thing, man, it's soaking up in that sponge. That's what was in the car like that. It wasn't in a car like that, you know. I went to my wife and I said, I need a favor. She said, what do you want? I said, next time you go to the $50 store, I need to go, and she said, well, I see, you know, you go to the dollar store, and you always get the $49 worth of crap, you know. I said, next time you go to the $50 store, you get me a sponge. You know, but everybody can realize now, what would happen if I take an injector and aim it at that? It's going to soak right up into it, right? What's going to happen to the ignition system now? At the time, it's harder anyway, because how do you get it running, right? It's running so lean right now, it's unbelievable. And even after it takes its belly full, it's still going to be running leaner than normal. So carbon cleaning, believe it or not, it's not just, now Runway's paying me a lot of money for this statement and stuff, right? Right, guy? Right, Bruce? Okay. Seriously though, carbon is a real big problem. It's a real big problem. And you know what? It's like deer. If you got carbon there, it's not just there. It's all over the place and stuff, in the combustion chamber and everything else. The whole time that you're trying to fire that ignition with a carbon buildup, number one, what's it doing to compression? Right? It's raising compression, right? And then what's it doing to the air-fuel ratio? It's making it leaner, right? What are the two things that make it harder? You got both of them now. So I can't tell you how many times I've seen people replace, you know, spark plug wires, you know, and cop coils and all that stuff, but they never took care of the original problem. And I love it. I say, what's the compression on that engine? Great. Now, wait a minute, what's great? Well, the book says 160 and it's 185. That's great. You know, wait a minute, hold it. Compression doesn't get better. You know, so when the carbon build up in a thing, you are burning the ignition system up in a vehicle. Really what it comes down to. Here's what I want to do here. The time, we're going to try to wrap this up. By the way, listen to me very clearly. This is Jim Linder. Anybody know Jim Linder? This is from Jim Linder. So I do a lot of stuff together. Here's what he's saying. Listen to me very carefully. The bends and the ends. The bends and the ends. Rails, fuel rails, you're getting problems at the bends and the end of the fuel rail. What's happening, especially on returnless, it's what it's doing, it's backing up, and causing everything to run lean. Watch for that, all right, I'm telling you. And you know it's kind of cool in a way? Without opening them up, and that's when you inject yourself, it gets in the rail, get used to tapping on the rail. How many times we tap on exhaust pipes, we can feel something too. Get used to tapping on the rails. You can't tap on a rail if you've never done it before and find a bad spot. All of a sudden hear this dead sound. You know, because of what you got a restriction in there. You got carbon actually building up in the rails right now because of that vaporization going on. All right? Here's what I want to do now. This is how we're going to wrap this up. Everybody remember me saying about, everybody says the SAI 2000 is a piece of crap? It is. You can hardly get a waveform at all to it. Listen to me very carefully. See up here the pair of glasses? If you put a SAI 2000 on a Snap-on anything, don't try to look at a waveform. Waveform's terrible, all right? Go up to the glasses and put it in text mode. And what happens now, it takes that lousy picture and does a great job putting it in text mode for you. And if you listen to what I said this afternoon, right, look what happened here on this car. This is the firing kV, this is the spark kV, and this is the burn time. Which one of these is the highest firing kV? That one, right? Which one happens to be the lowest over here? Okay, so we got a small problem on that cylinder, right? Look at this. Which one's the highest spark kV? So that problem, I'm asking everybody right now, is that internal or external combustion chamber? Absolutely positive. One time I said it's external combustion chamber. Spark kV is higher, it means they jumped out earlier there, right? Without even looking at the waveform now. But you got to hear what my point was? You have to know how it's supposed to work before you can use this your thing. Come up the rest of the story right there. Look, this gives a min-max. Look at the rest of the story there. That's a dead giveaway. Look at this one, how high this is. Look how low this is here. All right, 0.8, that's the lowest one. That's the highest one. Look at this here. Absolutely positive, 1,000%, that's a problem right there. I know I did it, but I'm proving it to how this can actually work for you, right? Again, what are you looking at there? Look at the burn time. Look at this one right here. Look at that. All right, now could that be external or internal? I was telling you earlier, right? Here's my person. You really can't tell because you need to see the whole waveform, right? But if I bring it over to this mode and the text mode, as soon as I look at that, right now, you don't know. You don't know if it's internal or external combustion chamber right now. Because all I know, here's what I got. Right? But now I got to find out what the spark kV is, though, right? Is there any even kind of hesitant here? You know exactly what it is right there by looking at that. All right? And again, I did it. All right? I'm good at it. I can do this. I learn from my students how to mess them up, right? All right. So my point is, look at that. Look at the Spark KV. That thing, remember that picture I showed you, that one that really jumped out early, and I said I did? There it is. There it is right there. All right? Very, very simple thing.
With the high spark, maybe external.
Yeah, external combustion chamber, because it jumped out early, right? Now here you go. Actually that's this scope right here, there. Now here's one of those ones I said later. Look, you got one here. You got all kind of issues going on here. But if I ask you, let's really spend some time, right? We definitely have a major problem here. This is a closet ejector right here. All right, no doubt about it. This is running really lean. Okay, this one here is not looking so good though either, is it? Right? But see how neat that is? No, everybody in this room can look at the Spark KVs across the board, all 6 of them. The Spark KVs are all about eco, right? So this problem is on that side, which is internal combustion chamber, right? Yeah, well, that's a good point. I'll tell you what, and that's a tough one. I love everybody says, oh, it should be nice and level. I want to see it go up a little bit, okay? So I'm going to tell you, even straight is a slightly rich. Very rarely, but if you're right that if you make, what I do sometimes, I'll bleed propane in the vehicle, and you can see it start to tilt down. It won't go too much further down. Once you get too rich, it's going to really start falling on its face. But I'll tell you what, it's really, really cool when you see the internet fire line going boom, boom, boom. Right? That's an ejector problem right there. Or when 1 or 2 Ford products have a lower plenum leak in them, you know. I think that's one of those things that come with it automatically, no option. They always vacuum leaks in them. Now this is the last one I want to show you. All right, look at this. Everybody knows about the thing called a Ford multi-strike? Everybody knows what a Ford multi-strike is? It hits it the second time, okay? It fires it once and fires it again. Why don't you do it up to about 1,400 RPM though? Because it doesn't have time to do it, and it doesn't have to do it, by the way. Under 1,400 RPM is ugly, okay? So they hit it a second time to clean it up, okay? Here's what I will show you. This is the cool part about it if you really get into the milliamp reading, right? Look at this here. This is 6-cylinder engine, so every third one of these is the same coil pack. Everybody take notice of something? The second one is short here, then 2 regular, short, 2 regular, right? The second one is not moving the car in the forward direction at all. I call it an EPA brownie point. Clean the cylinder up a little bit. But what can I tell this customer though? You got a coil that's going bad. You got a coil that's going weak. If I didn't see this second one, this one right here, these are all about the same. So the car's running fine. But I say right now, if this were an airplane, I wouldn't be flying it. Yeah. Now, I've been accused a lot of times of messing people's cars up because I can look at something and say, you know what, it's running good right now, but you got the beginning of a problem. You know, so it's almost like, okay, my car was fine, then 2 weeks ago you told me it was going to break down, now it broke down. What did you do? You know, it's because you know too much at that point. But everybody see that there? All right, that's why I say the power of a mini amp probe. Looking at that thing is very, very, very cool and stuff. Okay. Another thing I want to do, and Jared, can I have 2 seconds here? All right, this is a 4-cylinder. This is a 4-cylinder Mitsubishi Eclipse. Everybody hear about watch the tools you're using today, loading a circuit. If I had the time right now, I'd be asking everybody, describe loading a circuit to me. Most people really don't know what that really means. You use a test light, all right, and it's low resistance, and you're gonna bypass, you know, some of the current, and it can damage something. Okay, I don't have the time now, so I'm going to give it to you right out bat. This is a 4-cylinder vehicle, Wayspark, all right, with a on wholesale $918 computer that's been fragged. Okay, because somebody put a test light on this thing and to test the drivers in the PCM. Okay, see this coil right here? Right, we talked about this. This is one with it be a ballast circuit, right? Going up like that. See what I did? I marked it. You got 0.70 volts on 100 millivolts equals an amp. So that's 7 amps right there. This thing goes on, off, 7 amps, on, off, on, off, on, off. 2 cylinders, right? 2 of the cylinders, I want you to grab the secondary wire. The other 2 cylinders, I'm going to grab the secondary wire now, okay? Because the other one, look at that very carefully. Here's 0 down here. All right? Here's the other one, it's going 0.48, 480 millivolts to 710 millivolts. This thing is going on and off The driver's going on and off, but it's fried. It's not releasing all the way. So what I'm doing, I'm building a very weak magnetic field. You could just about see the spark on this other side here. And it was due to somebody using a tool that shouldn't have been anywhere near that vehicle, right? A low resistance component. That's why you got to get on board with the amp probes, the milliamp probes, and look at the work, right? Don't be looking at that voltage over time or probe and anything like that, okay? And the rest of it is real quick is that anybody's been hearing about compression waveforms, okay? Compression waveforms is the coolest thing out there. I've been doing it for years and years and years, but now everybody seems to be. This was sent to me recently, and they said, look at this, man. Look what we're able to see. We got a Honda here or an Acura here that needs a valve adjustment. All right? And I said, what do you mean a valve adjustment? I don't think I even put it in there, right? I want to show you real quick because it's thrown at me. Look here. They said, I did a valve adjustment. See here? The valves are a problem, all right? And then we adjusted the valves. And see right there, we got a little bit of noise, and we adjusted the valves again, all the noise is gone. Here's what I'm trying to tell you right now. Watch what you're doing. Don't be trying to move in and out of circuits you don't fully understand yet. This person was going to go and do a seminar on this, and I said, don't go to the seminar on this. I got to talk to you first. That's not a valve adjustment. He said, yes, it is. You saw the picture, right? See what it was before? And I said, yeah, I do see the picture, okay? Well, let me tell you what that is. I said very simply, when you did your valve adjustment, what you did is you killed a cylinder, you put a lead down a transducer, and you took the secondary ignition wire and you grounded it, okay? You had the two leads too close to each other the first time. When you did your valve adjustment the next time, you had the lead further away. He says, how did you know that? Because remember that bicycle pedals? When do you collapse that magnetic field in the coil? Right, before top dead center, right? See that compression peak right there? Where's the noise at? Right, about 10 degrees before top dead center. All right, so it had nothing to do with a valve adjustment. It had to do his placement of his two leads. So when you start jumping on a bandwagon and going deeper and deeper in new technology, which I do all the time, be careful. Be careful, you know what you're doing there, okay? Anybody needs any further explanation, all right, you can copy this down. I don't know if I put here. Matt's Auto, M-A-T-S, Matt's Auto, stands for Morton's Automotive Technical Service. Matt's Auto, all one word, at Verizon.net. And answer any questions, just do me a favor, please, and do a little research yourself on any car you're working on. I'll be more than happy to help you out. Matt's Auto, M-A-T-S-A-U-T-O, at Verizon.net, okay? I've been trying to come up here for years. I'm happy I was able to finally do it. Thank you very much.